está en España y al final el organismo que se encarga de la gestión de esas aguas es la Confederación Hidrográfica del Duero, de la parte española de dichas aguas. El río Duero es el segundo más largo de la península ibérica, es decir, teniendo en cuenta a Portugal y a España. Es el primero y más caudaloso de la península y tiene la mayor área. También es una cuenca, la parte española, que es muy heterogénea. Al final está rodeada de montañas prácticamente por todo su perímetro y en el centro existen grandes llanuras. Esto hace que contar con información hidrológica en tiempo real sea muy importante para nosotros.
Perdón, Guillermo. No nos
¿Sí?
están pasando las pantallas.
¿No? Tampoco.
No, tampoco.
A ver, voy a
Eh,
dejar de compartir y voy a empezar a...
claro.
mm,
A ver, te voy a quitar yo el compartir pantalla.
eh,
Ah,
¿Ahora? ¿Ahora lo veis en...?
ahora sí, ahora sí,
Vale,
ahora
ok.
sí.
Lo siento, perdonad. Estaba en esta diapositiva mostrando un poco la ubicación de la cuenca del Duero, donde está enclavada, compartiendo el río Duero, frontera con España y Portugal. Como decía, esto es muy importante para la gestión de la Confederación Hidrográfica del Duero, disponer de un sistema de información hidrológico que sea transversal. Es el SAI o el AGIS en inglés, es un sistema transversal que proporciona información a las 4 oficinas de las que está compuesta la Confederación Hidrográfica. Es una herramienta, como ya digo, que es fundamental en el día a día y nos da información casi en tiempo real sobre el estado en el que se encuentra la cuenca del Duero. Está compuesta de diferentes redes. En primer lugar, una red de estaciones de aforo que nos van a dar información sobre la cantidad de agua que está fluyendo tanto por ríos.
Information about the water that flows through.
Una red de estaciones que miden la calidad del agua superficial en tiempo real. Otra red que se encarga de medir el control, de medir el estado cuantitativo, la cantidad de agua que existe en nuestros acuíferos. También tenemos una red meteorológica que nos va a proporcionar información sobre variables como la temperatura o la precipitación, que son fundamentales para poder hacer pronósticos, como ya veremos más adelante. Y por último, las presas, que son infraestructuras críticas, también tenemos una red dedicada a su control. Todos estos datos que obtenemos de las distintas redes son recibidos y procesados por el Centro de Control de Cuenca, lo que podríamos definir un poco como el cerebro de la cuenca. En primer lugar, señalar que en cuanto a las estaciones de aforo, que...
Participando en assassino.
Sorry. En cuanto a las estaciones de aforo, actualmente tenemos 171 estaciones en ríos y 24 que están ubicados en canales. Como vemos en la imagen, todos los ríos principales actualmente constan al menos de una estación de aforos que nos va a dar esa información tan valiosa. Por ejemplo, en el caso del río Duero, que es el principal que tenemos, actualmente tenemos 15 estaciones desde su nacimiento hasta la frontera con Portugal. Los datos que son registrados son enviados cada 10 minutos al centro de control, bien por redes móviles como pueden ser GPRS o GSM, o bien por redes satelitales como es el VSAT. En cuanto a las estaciones de calidad, actualmente tenemos 30, que están ubicadas aguas abajo de los principales focos de vertido, para poder controlar si las depuradoras están cumpliendo con su cometido. Se miden variables como la temperatura del agua, la temperatura ambiente, el oxígeno disuelto, el pH, la conductividad, la turbidez, los óleos en suspensión, el ion amonio o la DQO. Al igual que en el caso anterior, se envían al centro de control cada 10 minutos. En cuanto al control de la piezometría, actualmente tenemos 134 piezómetros que están automatizados, es decir, que registran y envían el dato de la profundidad a la que se encuentra el nivel freático para poder controlar de esa manera el estado cuantitativo de las masas de aguas subterráneas. Estos datos son enviados una vez al día, pues no hace falta más. El nivel freático es no varía.
Information on a frequent basis, because the groundwater level does not change as often as it changes on superficial waters. So
167 estaciones que prácticamente coinciden con la ubicación de las estaciones de aforos. Y como veis en la imagen, en la cubierta, se puede apreciar que en la estación de aforos, arriba, está tanto el pluviómetro como un sensor de temperatura. En presas, además, como es fundamental poder medir o estimar la evaporación que se está produciendo en el embalse, existen estaciones compactas o completas, como se puede ver en la imagen, que nos dan además parámetros como humedad, presión atmosférica, evaporación, radiación solar y velocidad y dirección del viento. Finalmente, en cuanto a los embalses, actualmente tenemos 34 grandes presas que son que nos van a facilitar datos de el nivel del embalse, la capacidad a la que tenemos el embalse en cada momento y el estado y la posición de los aliviaderos y de las compuertas, para de esa manera saber cuánto agua estamos soltando en cada momento. En este caso, como se puede ver en la imagen, las presas se encuentran en las cabeceras de los ríos, normalmente en el perímetro de la cuenca, que es donde tenemos las principales zonas montañosas. Las comunicaciones se producen tanto por GPRS como por satélite, es decir, están dobladas, dado que son infraestructuras críticas y por si fallara el satélite, por ejemplo, poder seguir recibiendo los datos. Finalmente, todos estos datos, que como hemos visto son muchísimos, tened en cuenta que se envían cada 10 minutos. Por tanto, cada hora tenemos pues 60 datos y que al día son 144 datos diarios solo de un único parámetro y de un único punto. Esto hace que recibamos miles de datos al día y que es necesario gestionar. Para ello, aquí lo que se hace en primer lugar es validar el dato, es ver si es correcto o si es coherente y posteriormente almacenarlo para que distintas aplicaciones puedan hacer uso de ese dato. ¿Y por qué entonces es importante disponer de un sistema de información hidrológica? Básicamente, y como ya he dicho, porque para nosotros son los ojos dentro de la cuenca. Esto nos ayuda a poder operar de una manera más eficiente las distintas infraestructuras hidráulicas, como pueden ser las presas o los canales, y poder satisfacer así las demandas de los usuarios, producción de agua de consumo, producción hidroeléctrica, regadíos o usos recreativos. Por otro lado, estaría controlar y vigilar que se cumplen tanto la cantidad de agua que tiene que pasar en cada momento por los ríos, que viene fijada por los planes hidrológicos de cuenca, como la calidad de ese agua, que también tiene que cumplir con unos mínimos. Otro de los aspectos fundamentales es que sirve para ayudarnos a detectar y anticiparnos a posibles eventos que pueden ser peligrosos para nosotros o tener impactos negativos sobre las personas y los bienes, como pueden ser las inundaciones o las sequías. Todos estos datos que recibimos son muy importantes y son muy interesantes, pero no solamente ya para nosotros el organismo, sino que también es importante ponerles a disposición del público y de las distintas administraciones públicas que pueden hacer uso de ellos, como pueden ser IFAS, que es un sistema europeo de aviso de inundaciones, o nuestra propia Agencia Estatal de Meteorología, AEMET. Y finalmente, disponer de estos datos hidrológicos también nos ayuda a asegurarnos que cumplimos con los acuerdos internacionales, como puede ser el convenio de Albufera entre Portugal y España, para que en el Duero siempre existan unos caudales mínimos. La segunda parte de la presentación la quiero centrar en el sistema de ayuda a la decisión. Esto es una herramienta dentro del SAI, dentro del Sistema Automático de Información Hidrológica. El objetivo básico es intentar pronosticar y anticiparnos a posibles eventos de inundación o posibles crecidas, para que los impactos negativos que vemos en la imagen, intentar anticiparnos y poner medidas para minimizar dichos efectos. Para ello, contamos con varios modelos en los que, introduciendo una serie de datos al modelo, podemos llegar a hacer unos pronósticos. Para esto necesitamos, por un lado, datos observados y, por otro lado, datos de pronóstico. En cuanto a los datos observados, son aquellos datos que son medidos o que ya han sido medidos por nosotros o por otro organismo. Como datos de partida tendríamos dentro de la Confederación datos del nivel de los embalses, nivel y capacidad de los embalses, datos de caudal de las estaciones de aforos y los datos de pluviometría y temperatura. Asimismo, tenemos que sumar el radar meteorológico que nos proporciona la Agencia Estatal.
Data, the weather radar that we get from the Spanish Meteorology Agency, which give us real-time information about the level of
Pronóstico, si lo que queremos hacer es intentar predecir lo que va a pasar, necesitamos saber cuánto se espera que llueva. ¿Cómo? AEMET pone a disposición nuestra los resultados del modelo meteorológico Harmony-AROM, el cual tiene un horizonte de predicción de 48 horas. Es decir, nos da una idea de las precipitaciones que se esperan en España en las próximas 48 horas. Todos estos datos son introducidos al modelo y el siguiente paso sería crear o digitalizar la cuenca de estudio que nosotros queramos. En la imagen, y a modo de ejemplo, vemos cómo se ha dividido en distintas cuencas y subcuencas la cuenca del río Eresma. Para ello contamos con un modelo digital del terreno para
Guillermo,
obtener las elevaciones. ¿Sí?
Vamos en tiempo. O sea,
Vale.
que ya vamos ya...
Vale. Un mapa de usos y introducimos el resto de condiciones iniciales. La siguiente fase sería correr el modelo, que lo que buscamos es transformar las precipitaciones en caudal y ver cómo nos van a afectar. Y de esa manera, una vez que obtenemos los resultados, podemos tener datos como estos. En verde estarían el caudal observado, es decir, el medido por una estación de aforos, y en rojo el caudal que ha sido pronosticado, el cual es bastante similar, no es exacto, pero nos da una idea de los picos o de los picos del caudal que podemos tener y de las tendencias de caudal. Y finalmente, de cara al futuro, lo que tenemos que seguir apostando en la Confederación y en el resto de organismos de cuenca es por las nuevas tecnologías, seguir digitalizando, seguir controlando o sensorizando cada punto de la cuenca y para de esa manera poder anticiparnos a los posibles eventos. También otro de los aspectos que tenemos que considerar es introducir inteligencia artificial para que el modelo pueda aprender de eventos pasados y mejorar así el pronóstico de los futuros. Y finalmente, seguir compartiendo datos y integrar datos con las distintas administraciones públicas. Y con eso habría terminado. Gracias a todos.
Thank you. Thank you very much, Guillermo. Very interesting and very interesting presentation, and very useful, I think, for all regions. And I encourage all attendees and speakers, anyone participating in this event, to write your questions if you have to Guillermo, and we will discuss in debate part after all presentations, okay? And now I would like to invite also our colleagues from CAB, Östergötland, Sofia Bastiken and Robin Abili, to present development and testing of new technologies using passive water samples and GIS for water management. So, Sofia, or you or your colleague, the floors are yours.
Thank you. You can hear me?
Yes.
Yeah, I will start and Robin will continue during this presentation.
Okay, thank you very much.
Yeah, and you can see it, the presentation, right?
Yes. Yes.
Great. And yeah, so it's a bit diverse, this presentation. We will start in a broad way with GIS and water management, and then dive into the new sampling method that Robin will talk about. Let's see here. Yeah, again, we work at the County Administrative Board in Östergötland in Sweden. And I will start to talk about GIS and the water management. I think we have, let's see. Yeah, I briefly discussed this in another seminar before, but so it's not very long, but you will see the point. In our county, it's for us in Sweden, it's a large county, and we have a lot of monitoring data and coming from all different places in the county, and a lot of data generated, and we are supposed to take care of this. We have this national databases, of course, but we also have some responsibility to put them into the national databases. So this is a bit how to do with this handling of data. And we also, besides the raw data and all the data that's coming in from different directions, it's also that we have plans. We have local action plans. It could be diverse. It could be from, different actions that you want to take due to eutrophication, wetlands, where to put them, and it could be, different farming activities that are, advised. So we have a variety of actions that we want to take to save our waters and to make them better. And this is local action plans for us. And we also have a lot of actions that has already been taken. So we want to put this in a good way to visualize and to see what's left for us to do. And we also, besides that, we have a lot of stakeholders taking data or putting up data for us. We have municipalities who's monitoring a lot, and we have also different projects.
Acciones de control, acciones de monitorización.
So what we want is to put this all in national databases. So we work along with the national authorities to we have all of these big databases, but we also now are in a development phase of the GIS, because even if it's in a database, we also want to present it and visualize it in a good way. And we have listened to Norwater in this project, and we think that's very interesting. And we also have some ideas of how to make this good for us, because we think that we need a national GIS and national way to look at it, but we also need a regional way to look at it, because we have some regional information that's not used in a national way. So that's why we are in our regional authorities also working with this GIS. And that is to let's see here, management of big data, classifications, suggested measures and plans. Yes, because in external use, we have this water information system. I guess all countries have the same. We have looked at this before. It's our classification according to the Water Framework Directive, and we visualize it in one way. But then it's not as flexible. You cannot analyze everything in this system, so we need something else. And we also need story maps to even in a more easy way describe this to people that does not know everything about it. So we use this story maps as a tool. So this is for an external use, but we also need an internal use because there are a lot of people working at this authority, and we're working with actions for agriculture, industries, and everything. And everybody doesn't know everything about the water, quality of water. So we would like to make an internal GIS that puts together all the others working GIS, yeah, the maps and things that's really for internal use, but be able to put these more advanced national GIS on top of that and make analysis. So we are in a development phase now to do this, and we are doing it together with the national authorities as well. One thing that we're doing both regionally and nationally is automatic classifications, because we have done this semi-automatic, I would say, before, but now we would like to not dive into data every cycle of the Water Framework Directive, but have this generated automatically. And then we will need some more work. Yes, and this is just a small picture of what we are thinking. It's in Swedish, but maybe you can understand if I talk about it a little bit. We have this in, I don't know if you see, if I put my, can you see this marker? No.
Yes.
Yes, you can. Okay. So these are national databases in the top left corner. And then we would like to use the data coming from there and then take it into our internal GIS. And we have done this, and then we can make analysis, and we can also make story maps. So this is like a development picture that we are working on right now. Thank you. Yeah, Robin. We will change a little bit of this perspective now and go dive into sampling methods. Yes. I will stop sharing.
And I will start. Sorry, there's a small lag here. Now you should be able to see my presentation.
Yes, it's okay.
Great. So we, in addition to what Sophia said before, we have large, so not only large amounts of data that come in, but large physical distances to cover in our sampling. So we also want to try and develop some ways to make things automated, but instead of the approach we heard about earlier, we have come up with a little bit of a low-tech version as a way to have something that we can put in place that can move from between different water courses, but we use the same sampling technique, and that can fit in some of our much smaller rivers where we don't have the ability to have these large high-tech automatic systems set in place. So we really wanted to develop something that would allow us to sample, take integrated water samples for about a week that would allow us to have both whole water analyses as well as analyses of specific substances. And we wanted something that was low tech so we could transport it easily, use it easily, but also would give quality data that was robust and that we could validate. And so we collaborated with I can hide this. we collaborated with a university here in Sweden, the Swedish University of Agricultural Sciences, and Ove Jonsson is the one that developed this technology. And we came up with this system that he's calling time integrating microflow inline extraction. So essentially a sampler that passively works over time. And it's developed mostly based on this syringe and the negative pressure that is generated by pulling back the lock, which then pulls water up from the river system through this tube, and then it pulls it through these solid phase extractions. So you can add as many of these as you'd like in a series, and they can be focused on whatever substances are of interest to your monitoring program, such as pharmaceutical residues or other toxins. And then there's this narrow tubing that restricts the flow so that it will slowly fill into the syringe. And then the water that is collected in the syringe over time can be used for whole water analyses later as needed. And this system, as I said, allows for sampling of about a week. That's what works with our tubing size. And because it uses the syringe, you know the exact water volume, so you can also do quantitative assessments of your samples. And we have different sized water courses here in Sweden that we look at. So not the very large river systems that we've been seeing before, but many smaller streams, and even, so as you can see in this picture, very heavily man-made or altered systems. So this system is also flexible because you can attach it to a metal weight with a string and submerge it completely in the river. And then just use a hook like this to fish it out when it's time. You can set them up in medium-sized water courses where they're attached to a post and fixed to the bottom, so they're easy to read and just swap out syringes if you want to continuously sample them. And they can even be used in these very small trickling water systems we have here, where you can actually, sorry about the Swedish, hide the syringe on the shoreline and just run the long hose into the water system. And the application or implementation of this is quite simple. You just put your filters in a row, and we cover them with tinfoil because some substances are light sensitive. And then you just essentially pull back the plunger and set them in. And the only thing to really consider with putting them out in the water is that you want that intake hose to be in the middle of the water course or the river, so that you catch the active flowing water, and you don't want it to be too close or buried in the substrate so that it becomes dirty and blocked. And again, removing is simple and easy. You usually have a string to the shoreline, so you just pull up the system and equalize the pressure in the syringe, and watch out for your fingers. And then we have labeled bags that we put them in and keep them cold and send them off. So like any other water sampling you take with a scoop, you just have the water in the syringe and you seal it up and send it off. So there's also a paper here that I'm showing if you're interested in this technique and want to learn more. But we're really happy about the ability to use low-tech options in combination with our big data and high-tech samples, so that we can collect data in a number of places, so that then we can add more points to our maps, so that we have a sort of more fine-scale resolution along our water bodies of how things look. I think I will leave it there so that we stay in good time, and turn it back over to you, Jolanta. Thank you.
Okay, thank you very much, Robin. It's a very interesting presentation, and especially on the about the practical issues and sampling for organic materials as pesticides. So, but I expect that we will have later questions for you during the debate session. And now I would like to thank you again to you, and I would like to invite Georgios Katsouras from or Stelios Samios, because we have two presenters mentioned in the program to present water quality monitoring with the use of robotic boats from Greece. So, floor is yours. Please go ahead with your presentation.
Thank you very much, Yolanda. Yes, I will start the presentation right now, and I will share the screen. So I think now you should have the whole screen, the first slide in front of you, and we will present you with Dr. Samios, the head of my department of R&D department, ADAP from Greece.
Georgios, excuse me. Your screen is not in the full screen.
Ah, it's not in the full screen?
Not yet.
Not yet. Then maybe now?
We can see your screen, but not in a full version of screen.
George, Γιώργο, πρέπει να ανοίξεις full screen, αυτό λέει.
Yes, I will. Not now. Not yet, eh? You can't see
yet.
it. Sorry about that.
If you put the button F5, F5.
I will stop again the presentation. Excuse me, and then I will share screen. Share.
It is always confusing, and we're using technologies a lot, but always it is very difficult. But
sorry about that.
Sorry, I think if we can see, you can continue.
Okay.
I
think now it would be better, George.
Okay, we will go on like that. Sorry for that. So we will present you our good practice that has to deal with the water quality monitoring of rivers in Greece with the use of robotic boats. And we'll give the floor to Dr. Samios. Stelio, you can go on.
Okay, thank you. Thank you, Georgos. I spent only 1 minute to present our company, ADAP SA. ADAP is the largest company of its kind in Greece and serves about 4,400,000 customers. And the length of water pipelines is 14,000 kilometers. Also, the sewage sector serves 3,500,000 residents. So it is the largest of its kind, perhaps in the Balkans. ADAP means Athens Water Supply and Sewerage Company. The responsibilities include to provide the water supply and sewerage services, to install and operate water supply and sewerage systems.
Excuse me, Mr. Samios, but we only say the first. We are not.
Okay. It is only for a presentation of our company and the R&D department. Giorgos, are you listening?
Yes.
Okay. Our department is called the Research and Development Department. It consists of ADAP's highly competent team. Our responsibilities are implementation of European and national research projects, development and demonstration of state-of-the-art technologies, and our European programs are almost all of them are Horizon 2020 or Horizon Europe. Some of them assess and promote innovative circular economy, and now Giorgos Katsouras will present our program INCATS, that focus on better water management and the environmental protection of water.
So thank you, Stelios. Hopefully now you can see the third slide.
Yeah, okay.
Okay, at least that size. So why we use robotic boats for water quality monitoring? The problems that we face are that there were inadequate water quality data and the data management until recently that focused on small parts of rivers and lakes. And as we all know, there was not real-time monitoring during the last decades. At least it was not easy. The solution came with those innovative robotic boats that that make the monitoring easily, that they can approach points difficult to reach, and those boats are miniaturized, customized, and unmanned. So they provide also a safer working environment. And
tripuladas que pueden acercarse a puntos de difícil acceso. También
monitoring and visualization of the data that they produce. So that the robotic boats are a unique value proposition because they provide us fast and flexible data collection. They improved the management of catchments. They can scan larger areas, as you can see in the next slides, and they can give us a high level of customization. So I will show you how INCATS service can help us for the investigator of rivers, as a river investigator, actually. INCATS serves a range of stakeholders, such as water utilities, government agencies, public or citizen scientists. And we offer robotic autonomous boats equipped with sensors. There is a basic set of sensors and some novel sensors that are under development every day that we spend. So the basic set of sensors consists from the chlorophyll A sensor, conductivity, dissolved oxygen, and pH, and all together located beneath the boat, and collect real-time values from the parameters that we are interested of the surface of the catchment that we want to investigate. Innovative sensors and systems are an ISA sensor, that is an in-situ spectral analyzer that can detect nutrients, nitrate, BOD, COD, or other kind of parameters of interest in a specific wavelength, the wavelength. Another sensor that is innovative is for hydrocarbons and refined oils. There is a boat that is equipped with an onboard sampling system that is very useful, especially for lakes or rivers that it's difficult to approach on the traditional way. And in collaboration with partners from Italy, we can offer also an on-site system for the determination of E. coli, genomics, or even DNA analysis. EIDAP is very active in Greece. We have already visited more than 17 catchments in Greece, all around Greece, and we consider as an experienced operator. And I will present you some results of our investigations in Greece. And we choose two rivers, Acheloos and Kifissos rivers, that they two different kinds of rivers. Acheloos suffer from agricultural pressures and Kifissos from urban. Acheloos river is the second longest river in Greece, and as I mentioned before, suffer from agricultural pressure, especially downstream of the river. And here you can see in that graph how the robotic boat produce real-time results considering the chlorophyll A. In that graph, you can see with the blue color the lowest value of the chlorophyll A parameter, and with red spots the highest. So the interesting thing is that we have this image in real time in our mobile, in our screen back at the office during our deployment in the river. So it's a very useful tool for someone that is interesting of the quality of a river to find out immediately if there is a possible anthropogenic or natural pollution in the catchment. So you can see with in the red circle that we found some high values of chlorophyll A upstream of the river near the bridge of Katochi village with the values almost of 120 microgram per liter. If we see the results from the electrical conductivity, we also were able to find minute variations in the middle of the investigated area that can probably related with some kind of pollution in that area. For dissolved oxygen, we have similar trends and clear trends of variations, as you can see in 3 different points of the area that we visit with the robotic boats. I would also like to say that the robotic boat cover that area that is almost 2 kilometers in almost 1 hour. And as you can see, the boat went first downstream of the river and then continue up to the river till the village of Katochi. I will also give you some results from the Kifissos River, that is the longest river in Attica region, and suffer from urban pressures, especially downstream of the river, because the last 8 kilometers run along Athens and beneath a highway. In Kifissos River, we were also able to define minute variations. As you can see, chlorophyll A was higher upstream of the river and near Piraeus highway with the red line, while in the Saronikos Bay, the chlorophyll A values were below 4 microgram per liter, and indicating an oligotrophic state of the area. Similar trend we found for the electrical conductivity that you can see clearly here with the red line and the arrow, where we found the sea waterfront intrusion. The period that we visit Kypsos River was in the middle of the summer, so it was expected to have the sea inside the river, so the conductivity was really high, even 1 kilometer inside the mainland. Similar trends we found for pH and temperature, and I will conclude for this with the state of EIDAP's good practice that achieve a more thorough monitoring campaign, both in space and time, and provide us a significantly higher amount of water quality data, data that are very important for the new water framework directives, as we will see in a while. So the robotic boats allows monitoring of ecological status more accurately, with emphasis on phytoplankton growth, allows the collection of many discrete samples, and provides us with a representative coverage of the whole catchment. And it's something that we cannot achieve with permanent stations. So we think and we believe that robotic boats are important and for an holistic approach for monitoring of a catchment. And especially for rivers, it proved that could obtain minute variations due to anthropogenic or natural pressures. Some other results obtained from our practice are that can cover broader spatial extents in a shorter time, proved that can improve management of the site sampling plan, optimize monitoring strategies and the management of river basins, and last but not least, raising alerts in time to take action and protect end users and users. And for conclusions, we believe, as I mentioned before, that EIDAP tools could support the investigative monitoring programs of the Water Framework Directive in the future, and represent a valid and rapid tool approach in case of emergencies, because of their quick response in any case. Thank you very much for your attention. I hope I was clear enough.
Yes, thank you very much, Georgios, for very comprehensive presentation on the robotic boats. And actually, these type of technologies are very interesting, and I think it's our future. Still, I would like to encourage all attendees, maybe you have some questions, please write in the chat and we will announce in the debate session. And now I would like thanks again to Georgios and to Stelios Samios, and move to another presentation to Aidas Gudaitis from Kaunas University of Technology, and he's going to present GIS and water management in about implementation and possibilities in our country and with this technology. So Aidas, floor is yours.
Buenas tardes a todos los participantes de la conferencia. Soy Aidas Gudaitis de la Universidad Tecnológica de Kaunas, Lituania. Lo siento, pero no hablo bien en español, por eso voy a presentar en inglés. A couple words about me. I'm a researcher of Institute of Environmental Engineering in Kaunas Technological University. The last 15 years, I worked in IT project management field as a project manager. And most of my project was more or less related to GIS technology. Today, I'm going to talk about the usage of GIS technology for water management, representing the cases in Lithuania from utility company perspective. Today, there are many technology trends which influence how of us define and build a solution for business process optimization. Some trends like big data or Internet of Things are enablers of other initiatives such as smart cities or smart grids. But there is one trend I really want to focus your attention to. This is location intelligence. It covers most of the technologies listed above. First of all, that is related to big data, business intelligence, artificial intelligence, Internet of Things, and as well the main ingredient that is not listed here, but to my mind is the main driver for location intelligence. That is GIS. Probably most of you already know what GIS means, but for those who are not very familiar with it, I just mention a short definition of it. It is virtual data model of real world that includes static and dynamic data. I can mention that GIS is unique technology that can help to answer the main question. And the main question to which answer the GIS, it's where it is. When we know the phenomenon, where phenomenon is, we can ask and get answer to other questions like what is near around, how much, what are changes or will be supposed changes, how changes in time, why, and so on. So we have different aspects of this. GIS can be represented as a sandwich that covers different aspects of our life. We can collect assets, resources and tasks, infrastructure, processes, real-time data, digital elevation model, LiDAR, building information model objects, and so on. So geographic information systems are utilized in multiple technologies, processes, techniques, and methods. They are attached to various operations and numerous applications that relate to engineering, planning, management, transport and logistics, insurance, telecommunication, and different kinds of other businesses. Probably all of you have seen this COVID-19 dashboard before. Johns Hopkins University created it in February 2020. And during 1 year, it was visited more than several billion times. This example shows how important is spatial information in the world. I would say that the main reason of that is its ability to spread complex real-time information to all types of user groups. And what about water management? According to Esri, who is a global leader on enterprise GIS application, more than 9,000 water management companies in the world use its flagman, ArcGIS enterprise technology for water utility network management. In case of Lithuania, GIS technology is intensively used in more than 85% of largest infrastructure management companies. Here you can see the list of the largest ones that are representing the sectors from electricity and petrol to heat, supply, and telecommunication. At the moment, more than 20 water companies are using GS for infrastructure management purposes as well. They cover 50% of municipalities and serve more than 60% of total population of Lithuania. Talking about the reason why these companies decided to invest into GS system development, there can be mentioned 6 issues encountered by them. So one of them is ineffective asset management, as well as resource usage, as well as lack of information, who, where, and when is doing what, slow response to the problems, overdue problem solving, insufficient quality of provided services, sustained work time and financial losses, and the last but not least, ineffective investment allocation. The added value of GS for infrastructure organization stands on the 4 main pillars. Talking about first one, GS is considered as one of the best technologies for asset management. It provides best practices and industry standards. And GS is treated as #1 technology for infrastructure and utility network asset management. The second pillar is task management. GS provides effective tools for real-time event management and decision support. The third one is communication. This pillar provides effective means for collaboration between employees, different departments and institutions, as well as providing important information to public. The fourth one is smart systems that assures automation and warrant integration between businesses, business processes, and various information systems. There are a lot of talks about the vision of smart water management, information system development, as well as digital twins that would cover all aspects of water management and that will automate main processes or even substitute the humans. But reality is not such colorful as we can expect. Here you can see organizations' GS maturity curve provided by Esri. On the left side, we have geographically blind organization with minimum knowledge and awareness of GS benefits. On the right side, we have geographically advanced organization that uses smart means for water management. Thus saying the truth, more than 2/3 of water management companies in Lithuania only at the beginning of this journey. For the smart water management information system development, there are at least 4 steps forward. The first one is network inventory. The second is asset and task management. The third, monitoring and analytics of real-time. And the last one is real-time decision support based on big data, machine learning, and artificial intelligence as well. So let's talk a bit about the first step, what uses most of the companies which starting implementing GS technology. So GIS serves as a central database for spatial data that provides plenty of capabilities for data collection. In GIS database, we can store images, tabular data, unstructured data, vectorial, and different other aspects like real-time data from Internet of Things, LiDAR, and building information model elements. For water management issues, the data usually is collected from 3 main sources. The first one is data collection from fields. Because the water network is situated underground, the accuracy of network data is usually unsatisfied and need to be corrected. The correction can be done by surveying with high accuracy GPS equipment and GIS mobile applications. One source of information usually is emergency situations when the parts of the network are uncovered and can be measured by more accurate means. The second source for data collection is topographical data. Usually data are digitized from all topographic maps or are imported from computer-aided design geodetic files. The third source is tabular data, when you can import and integrate information from other systems like SCADA, CRM, ERP, or information system for asset management as well. For better coordination of complex issues related to topographic and engineering infrastructure data, in Lithuania, we already have national level information system, which is called TIS. Sorry for Lithuanian in this slide. The main task of it is to harmonize all municipal level topographic data to assure data consistency. The second step for GIS development in water management companies usually is network management, especially task planning and monitoring. Here's one example of task management processes: emergency response management. Effective emergency response system for water management company assures more effective use of its resources and time, as well as saved water, cleaner environment, and better image in front of the citizens. So this process usually starts from request of registration, analysis of incident, location, task allocation, then navigation, and in each step we can use different GIS tools like mobile applications or other means. Task performance and situation description and task closing. So here is example of one such system for task management in Kaunas water management company that is use ArcGIS application called GeoDispatcher that was implemented by HNIT Baltic, the leader of GIS solutions in Lithuania. So it has the application for dispatcher registering issues, and in different steps we have different mobile applications for task management, for navigation, for data collection, and all data goes to central dashboard for person who is responsible for coordination of works. So we can mention the main issues of this. It's task management in one place. We use standard management tools. It's easy to use, do not need any development, so it's mostly configuration. Information is provided in real time. For real-time network status and task monitoring, usually information dashboards are used. Technology allows integrate data from different IoT sensors that helps to react proactively to the issue and avoid possible accident before it happened. Last but not least, component of GIS-based water management is publishing of water management data. On the left side, you can see the map of coverage of water supply and discharge services of Klaipėda municipality. it's interesting that this application influences very much real estate prices in the area, because you, before buying some real estate, you already know if the services are available or not. On the right, you can see the example of a dashboard where is broadcasted the real-time information about the water network status in Klaipėda municipality for the public, that everybody can.
Esta es información pública, todo el mundo puede acceder a ella, todo el mundo puede verla, sobre el estado de la calidad del agua.
Places. The other GIS tools that are broadly used by Lithuanian utility companies are public polls or surveys before new infrastructure development or reconstruction is planned. Using these tools, we can better know whether the project is supported by public and make better decisions if a project is economically feasible. What is next? So usually we can talk about 3D or virtual reality tools or augmented reality. What network digital twins as a mainstream in near future. Here are some examples of technology already in place. Of course, it is only possible if all water network data is collected according to 3D GIS or building information model specification. So here are some example of technology that is already in place. But the need of specification implemented into national legislation is on the way, because without it, it's not possible to use such kind of tools because you don't have data on such level. Probably it looks like a miracle at the moment, but I can share you example of 3D infrastructure of Vilnius central city part. To my mind, it gives us positive hope that everything is possible and we will see so-called digital twins of smart network infrastructure in near future. So thank you very much for your attention.
Thank you, Aidas, for very comprehensive, as usual, very comprehensive presentation on GIS technologies for water management and GIS as such. So I hope that we will have some questions, and this is really very impressive. So thank you very much. And if you will have some questions, please let us know. You can write in the chat, or you can just leave this for the debate session. And now I would like to invite last but not least presenter, João Mamede from Environment Agency of Portugal, to present the project on prevention of floods and droughts risk in the Minho Lima International River Basin. So do we have? Yeah, João. Yes.
Hola a
todos.
Voy a partilhar. Hola, buenas tardes. Voy a partilhar mi pantalla. No sé si la están mirando.
No, todavía no.
Mira, entonces vamos a ver.
Still no.
Vamos a ver partilhar pantalla. Así. No sé si la están mirando. Voy a poner
Sí.
la presentación. ¿Y ahora?
Perfecto.
¿Lo están mirando? Bueno.
Sí.
Yes.
Buenas tardes a todos los presentes. Me gustaría saludarlos a todos desde Oporto y agradecerles por estar presente y con mi invitado.
Oporto, and thank you very much also for your invitation.
Bueno, me han pedido para hablar castellano e inglés y por proximidad y afinidad intentaré hablar castellano, pero un poquito, pues, aunque seguro me sale algo de mix de portugués con español o castellano. Bueno, voy a presentar el proyecto Risk Minho Límbia. Ha sido un proyecto cofinanciado por el Fondo Europeo de Desarrollo Regional FEDER a través del programa Interreg 5A España-Portugal, OCTEP 2014-2020 y ha terminado en el final de 2021. Risk Minho Lima pretende el diseño de medidas conjuntas orientadas a la prevención, preparación, predicción y una mejor gestión ante los fenómenos extremos, tales como inundaciones y sequías, en la demarcación hidrográfica internacional del Minho y Lima, a fin de mitigar sus efectos. Los parceros participantes han sido la Confederación Hidrográfica del Minho-Sil, chefe de fila, la Agencia Portuguesa do Ambiente, en que yo trabajo, la Universidad de Vigo y la Facultad de Ingeniería do Porto. Con este proyecto se pretende obtener un mayor conocimiento de la demarcación hidrográfica internacional para el establecimiento de mecanismos de gestión conjunta de sequías y alerta temprana ante inundaciones, permitiendo una mayor preparación y capacidad de respuesta en el territorio frente a los mismos. Es por ello que este proyecto no sería viable sin la cooperación expresa de todos los organismos responsables por la cuenca, de ambos los estados, así como los centros de investigación. Creemos que es importante reunir los centros de investigación y la administración. Mi presentación va a tener una breve presentación de la cuenca, las actividades del proyecto y las conclusiones. Entonces, empiezo por presentar el ámbito entorno territorial del proyecto, ya que las diferentes tarefas que han sido realizadas tienen impacto a diferentes niveles en toda la área. La cuenca internacional del Minho se ubica en noroeste peninsular, donde el último tercio tiene una fuerte influencia del clima atlántico. El proyecto Risk Minho Límbia tiene un área total de cerca de 20 kilómetros cuadrados, y solo 12% están en territorio portugués. De referir ainda que hace 24% de la población total de la cuenca está en Portugal. Voy a presentar las actividades del proyecto y a las que estuvo involucrada la Agencia Portuguesa del Ambiente. Bueno, en la actividad 1, análisis de las cuencas de los ríos Minho y Lima a nivel geográfico y hidrológico, para obtener un mayor conocimiento de la demarcación hidrográfica. Se llevaron a cabo una serie de actuaciones, desarrollo de una nueva cartografía de la demarcación, afinando la óptica desde la escala 1.25.000 a 1.10.000, para a continuación realizar un análisis de los recursos hídricos de la cuenca y su estimación futura a 2070-2100, considerando el cambio climático. Las tarefas han sido nueva cartografía de la demarcación internacional a escala 1.10.000, como ha dicho, nuevo inventario de recursos hídricos considerando el cambio climático en 3 escenarios, 2011, 2040, 2041, 2070 y 2070, 2100. En la actividad 2, un plan de sequía para la demarcación internacional del Minho Límbia. Se analizaron entre los índices existentes de sequía, aquellos que representan de forma más precisa el área de estudio y potencialmente se adaptan los ya existentes para la elaboración de un plan técnico de sequía conjunta para toda la demarcación internacional. O sea, se han establecido nuevos indicadores de sequía, un plan técnico de sequía conjunto. En la actividad 3, nuevo sistema de alerta temprano frente a inundaciones en la demarcación internacional. Mejora de las prestaciones del protocolo de alerta temprana de inundaciones de la Confederación Hidrográfica del Minho-Sil para la obtención de un sistema completamente fiable y eficaz, universalizado para toda la demarcación hidrográfica. Mejora de los datos disponibles, datos de modelado y datos de estaciones, desarrollo y adaptación de herramientas de modelado, bien como elaboración de un protocolo de comunicaciones entre España, entre la Confederación Hidrográfica del Minho-Sil y la Agencia Portuguesa do Ambiente. En la actividad 4, sistemas de control de cuenca y medidas de retención natural contra inundaciones. Articulación de sistemas de control hídrico que proporcionen un contraste de los resultados del sistema de alerta temprana y un mayor conocimiento del estado de la demarcación y los problemas provenientes de cada zona, así como diseño de medidas de retención natural contra inundaciones en ubicaciones específicas de la cuenca del Limia. En esta actividad, las tarefas eran ampliación de las redes de monitorización, el SNIR de Portugal y el SAI y SAICA de España, de la Confederación Hidrográfica Minho-Sil, y también diseño de medidas de retención natural contra las inundaciones. La APA, concretamente, o sea, la administración de la región hidrográfica del norte, que se ubica en Loporto, ha estado envuelta en prácticamente todas las actividades, más en las siguientes actividades tuvo una participación mucho más activa. O sea, en la actividad 1, relativa al análisis de cuenca, concretamente en la tarea de recolección, tratamiento y sistematización de la cartografía de la parte de la cuenca hidrográfica portuguesa. En la actividad 2, elaboración de plan de seca conjunto, un plan que ha sido elaborado en colaboración con la Confederación Hidrográfica del Minho-Sil. En la actividad 3, relativa al sistema de alerta para inundaciones, se ha participado en la definición y establecimiento de un protocolo de comunicaciones entre APA y Confederación Hidrográfica del Minho-Sil. En la actividad 4, relativa a los sistemas de control de retención, participamos en las tarefas de ampliación de las redes de monitorización hidrométricas y en la elaboración de un proyecto conceptual, estudio, que promoviese la implementación de medidas de retención naturales, o sea, medidas verdes. En la actividad 6, fuimos responsables por la organización de la comunicación y la jornada de encerramiento del proyecto. Entrando en detalle, pudimos decir que en el ámbito de la actividad 1 se sistematizó la cartografía portuguesa a escala 1/10.000. Durante esta fase fueron identificadas algunas incompatibilidades entre la cartografía portuguesa y la española, principalmente en las zonas de frontera. Debido a esas incompatibilidades y problemas, la Confederación Hidrográfica del Minho-Sil ha realizado un vuelo LIDAR que produjo una nueva cartografía a escala 1/10.000, permitiendo aumentar el nivel de análisis y conocimiento del territorio, incluyendo un inventario más exhaustivo de los recursos hídricos. Esta cartografía fue producida y homologada por el Instituto Geográfico Nacional de España, tal como muestra la publicación incluida en el lado derecho de la diapositiva, y ha establecido un protocolo entre Confederación Hidrográfica y el IGN. En la actividad 2 se definiron indicadores de sequía para el territorio portugués, de forma que existan referencias conjuntas para los dos países. O sea, se elaboró un plan de conjunto de sequía para la cuenca internacional del Minho-Limia. La legislación española obliga a que las diferentes confederaciones hidrográficas elaboren ese plan, por lo que consideró iniciar este proceso y establecer las líneas base para una tarea que habrá que responder teniendo en cuenta los escenarios del cambio climático. El plan de sequía tenía como objetivos definición de objetivos de gestión, formación en particular para las entidades públicas, protección civil, municipios, agricultura y sociedad en general. Establecimiento de protocolos de actuación que mitiguen o disminuyan el efecto de las sequías, ya que estamos en el sur de Europa y es un problema que tenemos que enfrentar. En la actividad 3, se han establecido los principios para la elaboración de un protocolo de comunicaciones para el intercambio y transferencia de datos de cantidad y de calidad de los recursos hídricos. La importancia de esta tarea ha sido reconocida por la CADC, o sea, el Convenio de Albufeira, que la incluyó con una actividad prioritaria, con vista a la definición de un protocolo de intercambio de datos entre el Estado portugués y el Reino de España para todas las cuencas internacionales. Es importante mencionar también que ya existen comunicaciones de datos entre los dos países. pero consideramos que no se ajustan à evolução tecnológica atual. Ou seja, hay una necesidad de implementar protocolos más rápidos y más eficaces. En la actividad 4, que incluye la instalación de estaciones hidrométricas y la realización de un estudio de medidas de retención natural contra las avenidas e inundaciones. Fueron empleadas las redes de monitorización tanto en Portugal como en España, como ya he dicho. Conviene remarcar la importancia que estas estaciones automáticas representan en la monitorización de los recursos hídricos de APA, de Portugal, y de la Confederación en España. En el caso particular de la cuenca de Limia, en Portugal, se torna necesario mencionar que en esta cuenca se ocurren regularmente fenómenos de riadas, inundaciones, con grandes prejuicios para las personas y bienes, debido a que los principales núcleos urbanos crecieron en el entorno del río Lima y Vés, tales como Ponte da Barca, Ponte de Lima, Viana do Castelo y Arcos de Valdevés. APA ha realizado un cuidadoso análisis de los posibles puntos para la ubicación de estas dos estaciones hidrométricas, tomando como base la conjunción de varios factores, o sea, tales como localizaciones más problemáticas, o histórico de estaciones ya existentes, en función de la carencia de datos asociada a la importancia que representan para la anticipación de medidas en escenarios de crisis. En rojo se indican los 5 sitios donde se equipararon inicialmente para la instalación de estas estaciones, en el Minho Internacional y en la subcuenca del río Vés, en el Limia. Los puntos rojos, han sido los que fueron finalmente seleccionados en el río Minho, junto a la desembocadura, creo que es así que se dice, la hoz del río Moro, en el municipio de Monção, aguas arriba de la villa, que lo permite evaluar las afluencias del Minho y del Moro para anticipar medidas o acciones en la área inundable de Monção y Valencia, que está aguas abajo. El otro, en el río Azere, junto a confluencia con el río Vés, que en el municipio de Arcos de Valdevés, que también aporta un caudal muy significativo al río Vés, que tiene mucho impacto en los núcleos urbanos de la vila de Arcos de Valdevés y de Ponte da Barca, debido también a las afluencias del río, la junción de las afluencias del río Lima y del río Vés. Importa también subrayar que estas dos estaciones quedaron instaladas aguas arriba desde las zonas críticas de inundaciones identificadas en los planes de gestión de riesgo de inundación que tenemos que hacer en el ámbito de la directiva inundaciones. El caso de Azere, cabe señalar que el primer ciclo, fase de los planes, o sea, en el primer plan que hicimos, la gestión de riesgo no fueron identificadas áreas críticas de Ponte da Barca y Ponte Lima, con una ligera variación en el segundo ciclo, ya que se añadió también la área crítica de Arcos de Valdevés. La estación del Minho, en la hoz del Moro, queda aguas arriba de las zonas críticas de Monção y Valencia, de parte portuguesa, y también de Tui, de la parte española, o sea, produce datos para nosotros y para nuestros compañeros de la Confederación Hidrográfica del Municipio. Bueno, la estación hidrométrica de la hoz del Moro ha sido instalada en los finales de 2018 y está integrada dentro del Sistema Nacional de Información de Recursos Hídricos, que es el SNIR, que ha hablado ya. Esta estación recoge datos hidrométricos para las aplicaciones del Sistema de Vigilancia y Alerta de Recursos Hídricos, que es una herramienta que prevé las inundaciones y las riadas. Lo mismo pasa con la estación de Fontebella, en Arcos de Valdevés, instalada en 2018, que también está integrada en el sistema SNIR y reporta también datos al SVAR. Bueno, dentro de la actividad 4 se elaboró un estudio o diseño conceptual para aplicar medidas de retención natural contra inundaciones. O desenho deste projeto pretendia ter um efeito pedagógico mediante a consciencialização das diferentes entidades, concretamente os municípios, de los cidadãos em geral, para que adotem práticas mais respeituosas com o meio ambiente, tendo em conta as diretrizes da Agência Europeia do Meio Ambiente para promover o uso das medidas verdes em lugar de soluções de construção pesadas como hormigón e muitas coisas que não hacen bem. Também se pretendia dar um exemplo das medidas que se definirão para o segundo ciclo do Plano de Gestão de Riscos de Inundação. Assim, se definiu para a área de estudo um tramo do Rio Lima, na parte baixa desta cuenca hidrográfica, situada no município de Viana do Castelo, que inclui uma longitude total de 3,7 km, águas abaixo de Ponte de Lanheses, onde se identificaram problemas de circulação da água durante os períodos de alto caudal. O estudo foi realizado sobre a base de 4 objetivos principais: mitigar os impactos associados aos riscos de inundações mediante o estabelecimento de zonas de inundação preferente, contribuir à diminuição dos efeitos das inundações do rio Limia, recuperar a ribera da zona e a consequente funcionalidade dos sistemas naturais de ribera, fomentando a conectividade das zonas circundantes. E, por último, incorporar soluções integradas que são as medidas de retenção natural, medidas verdes, já referenciadas na anterior diapositiva. Bueno, se contribuiu com conteúdos a nível da comunicação, também se contribuiu com conteúdos para a difusão do projeto na região hidrográfica do norte de Portugal, internamente na APA, porque a APA tem la gestión, la coordinación de todas las diferentes administraciones hidrográficas de Portugal. Se ha participado en seminarios, en diferentes workshops sobre el tema, se trabajó la involucración de las diferentes partes con el proyecto, stakeholders de la administración, particulares. Organizamos, la APA ha organizado la jornada de encerramiento de un seminario web sobre los recursos hídricos ante el cambio climático y los fenómenos extremos. En las conclusiones, bueno, como conclusión, podemos decir que estamos en una era muy tecnológica en que los datos son cada vez más importantes para generar información, que a su vez genera conocimiento, como todos sabemos y como todos estamos mirando hoy por la tarde, porque ha sido una cosa de los datos, la importancia de los datos. Y ahí la importancia de la recolección de datos a través de las estaciones de control instaladas, lo que sin duda contribuirá a mejorar nuestro conocimiento sobre las masas de agua y a apoyar los procesos de toma de decisiones en la gestión y planificación de los recursos hídricos. Este proyecto nos permitió aumentar el conocimiento sobre la cuenca hidrográfica, objeto de estudio, desde una perspectiva internacional, integrando las diferentes visiones de los dos lados de la frontera, pero de un modo más amplio, ya que el medio ambiente y los problemas asociados no tienen límites geográficos. Fue también un espacio de debate y discusión para abordar problemas comunes o idénticos que independientemente de las normativas y organizaciones locales pueden tener soluciones idénticas o similares basadas en el principio común de una gestión coordinada y articulada. En este contexto fue una oportunidad de compartir experiencias, enfoques y conocimientos, obviamente con la participación y la importante colaboración del mundo académico, lo cual tiene un papel fundamental en la transferencia y difusión de conocimiento a las organizaciones y a la sociedad civil. La pertinencia e importancia de este proyecto se manifiesta también en la creciente necesidad de sensibilizar a los diferentes actores del territorio, pero principalmente a la población en general, sobre la relevancia del cambio climático y el aumento de ocurrencia de fenómenos extremos. También cabe mencionar y reforzar el papel de la cooperación transfronteriza y la articulación entre los organismos responsables de la gestión y planificación de los recursos hídricos entre Portugal y España. Por último, cabe señalar que este proyecto ha contribuido efectivamente para el desarrollo de las capacidades internas de las organizaciones con la introducción de medidas en los procesos de gestión para aumentar la capacidad de prevención, preparación y respuesta ante los fenómenos extremos. Sin embargo, creemos que este proyecto es solo un primer paso que crea una ventana de oportunidad para su continuidad y profundización, dada la relevancia de estos temas ante los actuales retos que se plantean en el campo climático. Bueno, muchas gracias por vuestra atención. Para conocer más detalle lo que ha realizado el proyecto, os invito a visitar la página web del proyecto, que lo voy a colocar no enlace en el chat. Muchas gracias y estoy ahí para las cuestiones que tengan.
Thank you, Joao, for very nice, excellent presentation. And I really would like to ask if somebody has a question to our presenters. I don't see, and maybe let me remind what we have heard in this session, session dedicated for water technologies, water resource management and technologies. And actually,
Yolanta,
yes?
si me permites, simplemente antes que comentes el tema, no es una pregunta, pero es que ya que es la última presentación, la de Joao, la reflexión o la conclusión, no sé si los representantes tanto de lo que es APA como de Confederación Hidrográfica, la importancia que tiene la compatibilización de los datos para su posterior gestión y tratamiento y explotación en las cuencas internacionales. Lo importante que es y todos estos proyectos de cooperación en todos sus ámbitos, transfronteriza, transnacional e interregional, lo importante es que son para a veces coordinar, si cabe más, a las diferentes administraciones para que después, bueno, pues todas esas explotaciones pues den sus frutos y sean satisfactorias para lo que es la gestión de los propios ríos. Era simplemente eso. Disculpa, Yolanda. No sé si Joao o Guillermo quieren comentar algo al respecto.
Sí, yo puedo comentar que es muy importante, lo sentimos a diario, que es muy importante hablar con nuestros compañeros de Confederación Hidrográfica de Miño-Sil, que con Confederación Hidrográfica del Douro, que también lo hacemos, porque el territorio, como ha dicho, es continuo, no hay fronteras, la agua no las conoce. Y las cosas que pasan en medio ambiente no conocen fronteras. Por eso creo que estamos en una era digital, los datos son muy importantes, lo intercambio, lo conocimiento, porque eso nos hace mejorar nuestra gestión. Y creo que las administraciones, las universidades cada vez más tienen que caminar juntas para mejorar la gestión, porque la agua es algo que está siendo muy importante, mas va a ser mucho más importante. Gracias.
Yo añadir también que estoy completamente de acuerdo con vosotros. Al final la cooperación y compartir los datos es fundamental. Los datos, aunque nosotros como Confederación
Even if we as Hydrographic Confederation, well, even if we gather data, we feel that the use should be extended or spread as much as possible to citizens so that they are warned.
De organismos tanto europeos como españoles, como de países vecinos, como en este caso Portugal. Al final, compartir nos hace grande a todos. No es algo que sean datos, digamos, propios de algo, sino que al final es compartirlo y eso nos va a hacer mejorar a todos.
Okay, thank you very much, Jesus, for your initiative to ask Joao and Guillermo on these aspects, but now I would like to invite all the attendees and speakers a little bit for the short debate, maybe, if we still don't have any question from the audience. I have a general question to all of you, because you have said that data is essential. Without data, we cannot manage. And you have presented already different technologies. I would like to ask you a very general question. Maybe it is possible a little bit to comment on those technologies, what was presented, or how these technologies could help for water resource management and decision making, especially in their region, and maybe replication for other regions. Maybe just few comments from all the participants, all the attendees in this session on technology session. And I would like to start first with Guillermo. Okay, please.
Perfecto. Al final, bueno, nuestra presentación estaba centrada en el sistema de información y, verdad, que tenía la traducción y me estaba volviendo loco. Entonces, los datos nos pueden ayudar a pronosticar cómo va a ir en un futuro un evento potencialmente peligroso para alguna población o para ciertos bienes. Al final, la digitalización, entendiéndose en su amplio significado, lo que nos está proporcionando son herramientas para poder tener más datos en tiempo real de lo que está pasando y también con herramientas de pronóstico apoyarnos en eso para tener conclusiones y podernos fiar.
Okay, thank you, Guillermo. And maybe we can continue with Sophie and Robin. If you may something add on what I asked already about this general question to all presenters. Still Sophie and Robin with us. Okay.
Yes, I can. We were discussing the GIS in Sweden and the regional application of the GIS, and I think that's if you ask about the decision making and the tool for decision making, I think that's one of these what we're trying to do. We're trying to take the national GIS to regional, more usable GIS for our decision making, so we can adjust it for our needs when we need to apply it in some kind of regional decisions.
I can also quickly add that we're also working on having a more automated system. I think some people mentioned a sort of machine learning or something that we don't have to manually update all of our layers in GIS, but rather that we have a system when we get new measures that our maps and our data get updated quickly as well, so that it's not so much manual work as well. So.
Okay, thank you, Robin. And what about Stelios or Georgios on these robotic possibilities for decision making? What would be your comment?
Yes, I don't know if Stelios also wants to add something. I will start explaining that in the framework of INCAT's project, there was this intention to integrate this great amount of data into a decision support system. And actually, we were able to start the DSS for a lake, not for a river. For Lake Iliki, the main supply, one of the reservoirs of Athens region, and in cooperation with the National Technical University of Athens, they started a decision support system. But I think it needs more more data and more historical data to create one. But I think that with the robotic boats, we have a tool to in the future to have this kind of tool, because everything I think goes in that direction. All data in one cloud and then continue to a support system. Stelio, I don't know if you want to add anything.
No, it's okay. I think it's the best combination of real-time data, of parameters, basic parameters that indicate instantly where the pollution. Yes, the pollution point. Yes, I think so. That's my opinion.
Okay, I see that we just have a time for the coffee break, but still maybe we will spend a few minutes more for Aida's comment and for Joao comments also on that point, what I mentioned before. And still we have from Jose Vitorino one question to, I think, to Sophia and Robin regarding the TIMFI project. So Aida's maybe a very short comment on GIS and for decision making.
Okay, so probably we talked about different kind of technologies we'll use in different countries. So probably technology is not the main issue here, but I see the issue of data quality, of specifications, of standards for data quality. So this main issue, I think, because in different countries or even in regions, in different municipalities, we have different level of detailness of data. So if we talk about central, the big cities, they have very detailed information and even real time. And if we talk about some country regions, rural regions, it's very difficult situation here. So one is this issue. I think we should have some kind of standard, the lowest level, what should be reached in all regions in different countries. And the second is competence. So it's we should have a knowledge. So sharing a knowledge, it's the main issue, I think, because if you have data and you have technology, but you don't have who is working with it and make decisions, because decision makers mostly don't use technologies. We need this part, this intelligence part, which is people and its knowledge to analyze and provide these insights for the decision makers. So if we don't have this and we will not invest in our education, it will be nothing. It's money to the ear, probably. The technology will not help here. Thank you.
Thank you very much. And so, Joao, maybe you can also contribute with your thoughts on that topic.
Bueno, como se ha dicho, como se ha ya dicho, creo que estamos en una era tecnológica y los datos nos enseñan muchas cosas, o sea, nos dan posibilidad de hacer modelación, herramientas de gestión. Entonces, lo que es preciso también, lo que hace falta es también, como ha dicho Aidas, para educarnos los decisores de quien toma las decisiones y los técnicos, porque si miramos los datos con atención, estamos siempre aprendiendo algo y es necesario tener herramientas que nos ayuden a percibir los datos con modelación, con gestión, o sea, estamos en la era de los datos, por eso creo que estamos aquí en el seminario Big Data. Es lo que tengo que decir porque no hay mucho más que añadir.
Thank Thank you very much. And maybe Sophia or Robin, could you please a little bit, just half a minute comment on TIMFI sampling technology? Can it be expanded to more than 7 days, or the degradation of the sample is too great?
Yeah, I think that the main limitation set by 7 days is more the volume that the syringe can hold. So it depends a bit more on the diameter of the tubing and the flow of the river. So I think it could be extended if you had a narrower tubing or a sort of stronger filter before the syringe, so that you just slowed the accumulation of the water into the syringe. You could have it out for 10 days or maybe 2 weeks, but it would depend on your water flow.
Okay. Okay. Thank you very much, Robin, for your answer. And I see that we are the used 5 minutes more for our panel. I would like once again thank you to all panelists, to all presenters for your nice presentations. And I hope that these materials could be shared with all the partners and partnership and all attendees of this panel. And I would like to thank you again for your time. And maybe we can all agree that next panel we will have after 10 minutes at 4 instead of 5 to 4. But it is not up to me. Maybe Raul can help in this.
10 minutes,
we used 5 minutes. Sorry for that.
Yeah, okay, don't worry. It's perfect. Thank you very much to everybody. See you in 10 minutes.
Thank you. Thank you and bye-bye. Thank you all.
Hola Javier, no sé si me oyes. Antigoni.
Sí, hola, buenas tardes.
Hola Javier, no te vemos.
Ah, un segundín.
Ahí
Creo que ya
estás.
aparezco por aquí.
Apareces.
Bueno, yo soy David Cuadrado, sustituyo
Ah,
a Javier Pablos porque ha tenido una urgencia y no ha podido estar presente.
vale. O sea, vas a hacer tú la presentación. Bueno,
Sí,
pues,
sí.
pues lo comentas y ya está, ¿vale? Tenemos... ¿cómo lo vas a hacer? ¿En castellano?
En castellano, sí.
Vale, pues entonces... vale, bien. Tenemos Antigoni, es la moderadora, ¿vale? Mira, de todas formas, no sé si vas a
So,
necesitar...
Jesus, wait a moment. Antigoni, you must switch on your audio because we don't listen to you.
Oh, sorry, yes.
Okay, excellent. So, because you are the moderator in this panel, so now it's perfect.
Okay. Can you hear me all right?
Yeah, perfect. We hear you perfect. Okay.
All right, because I don't have a headphone with a microphone.
Don't worry.
It's the camera's microphone.
It's perfect. So, because you are the moderator, you can start.
I can do what?
Start, begin.
I can start. We are all here. We don't wait someone else.
No, I think everybody's here.
All right. Hello, everyone then. Let me welcome you all to the third panel, Good Practices and Best Technologies Available. I'm Antigoni Goufa, Public Servant for Support Office of the General Directorate for Sustainable Development and Climate Change of Attica Region, Greece. And I'll be the moderator for the panel. Please forgive me, I apologize in advance if any mispronunciation of your names occurs. I think we don't need to delay. We should start right away unless someone wants to say something. No? So we can start and give the floor to our first presentator, Mr. Xavier Pablos Aragon, Public Infrastructure and Environment Society of Castilla León. The floor is yours.
Javier, puedes empezar.
Hola, buenas tardes a todos. Bueno, yo soy David Cuadrado. Javier Pablos no puede estar presente porque ha tenido pues, una incidencia de última hora y le voy a sustituir yo.
Perfecto.
Bueno, Somacil es la empresa pública de infraestructuras y medio ambiente de Castilla y León y entre uno de sus muchos cometidos pues está la construcción, la promoción, la ejecución y la explotación de depuradoras. En estos últimos años la ejecución de la Junta de Castilla y León ha ejecutado un plan de depuración para los municipios de 10.000 a 500 habitantes equivalentes. En la actualidad, los municipios más grandes pues, ya están ejecutados prácticamente en su totalidad y los que quedan por realizar pues, son los menores de 2.000 habitantes equivalentes. Recientemente se ha iniciado un plan para la ejecución de todas estas actuaciones. Bueno, voy a ver si consigo compartir la pantalla y les voy mostrando una pequeña presentación en la que se pueden ver un poco los datos. Creo que ya se ve bien.
Perfecto, sí.
Vale, pues como os comentaba, actualmente estamos en un plan para dotar de depuración a los municipios que están entre 500 y 2.000 habitantes equivalentes. Este plan pues, cuenta con un total de 265 actuaciones repartidas en las 9 provincias de la comunidad. De todas estas actuaciones, pues actualmente se encuentran en ejecución 2 plantas. Una planta ha sido terminada recientemente y ya está en explotación, está en mantenimiento. Y tenemos 24 plantas en licitación, que se ejecutará la obra inminentemente y entrará en servicio a continuación. Aparte, tenemos pues, 9 plantas con el convenio aprobado, 4 plantas también con el convenio aprobado. Esto es un paso intermedio antes de la ejecución de las obras. Estas plantas, bueno, pasamos a la tipología de las plantas que se van a ejecutar. Las plantas de 500 a 2000 habitantes equivalentes hemos hecho una división, como podéis ver, de 500 a 999 habitantes equivalentes, de 1000 a 1500 habitantes equivalentes y de 1500 a 2000 habitantes equivalentes para mostrarla, para elegir la tipología de estas depuradoras. Todas estas depuradoras pues, se basan en la experiencia acumulada por parte de los servicios técnicos de la Junta de Castilla y León, por la experiencia acumulada por el redactor de todos estos documentos, que ha trabajado pues, para la Junta de Castilla y León, Acuages, la Junta de Castilla-La Mancha, y del manual de explotación de pequeñas localidades realizado por el CEDES. La tipología empleada, pues como os he comentado, va de 500 a 99 habitantes equivalentes y hemos establecido 3 prioridades en función de la disposición de parcelas, tamaño de las mismas, orografía del terreno. Nuestras primeras prioridades son los humedales horizontales, que son los que más terreno ocupan y más necesidad de una orografía plana necesitan. En caso de que la parcela pues, no cumpla todas estas necesidades, pasaríamos a macrófitas en flotación, también un tipo de humedal artificial, que requiere menos superficie, y en el caso de que dispusiéramos de una parcela no adecuada, con una orografía difícil, con poco terreno, pues pasaríamos a los filtros biológicos. Esta división pues, se basa principalmente en costes de explotación y mantenimiento y sencillez de explotación de las plantas. Para poblaciones de 1000 a 1500 habitantes equivalentes, la opción elegida es biodiscos, CBRs, contactores biológicos rotativos. Normalmente con una línea y unos 10.000, 12.000 metros cuadrados de superficie, pues tenemos suficiente. Y en caso de que la población sea 1500, 2000 habitantes equivalentes, pues se va a una solución similar a la anterior, pero en 2 líneas paralelas. En caso de que la depuradora esté en una zona normal que no requiera unos parámetros de vertidos especiales, pues los biodiscos no llevan eliminación de nitrógeno. Y en caso de que se trate de una zona sensible, pues sí hay que dotar a los biodiscos de una sección para eliminar el nitrógeno. Ya pasamos pues a una descripción más general de la planta. En el caso de los humedales, nuestra primera y segunda opción, pues contamos con una línea de agua y línea de fangos. Los elementos con que cuenta la planta pues son la obra de llegada, lo podemos ver en esta imagen detrás. Tenemos una obra de llegada donde llega el vertido desde el pueblo. Disponemos de un pretratamiento donde se eliminan los gruesos de mayor tamaño. Disponemos de un pozo de bombeo que nos da la cota necesaria para la explotación. el tamizado, donde eliminamos partículas de hasta 3 milímetros, una zona de alivio para eliminar los caudales excesivos en caso de tormenta, un tanque INJO dispuesto en una sola línea, un tanque de fábrica, ejecutado en hormigón, un tratamiento biológico, en este caso, en la primera opción que vamos, es humedales, tanto de un filtro hub con macrófitas sobre un filtro de grava, o bien, si disponemos de menos espacio, con macrófitas en flotación, y la obra de salida y medida de caudal, pues porque necesitamos medir el caudal tratado en la planta. Asimismo, esta planta dispone de una línea de fangos con un tratamiento con un digestor primario, integrado en el propio decantador primario. En el caso de que no dispongamos, esta sería la solución de los humedales artificiales, las macrófitas, filtro hub en gravas. Esta sería la solución. Al final, el esquema de tratamiento es el mismo. Tenemos la obra de entrada, tenemos el tamizado, tenemos el tanque INJO y tenemos, en este caso, las macrófitas en flotación. En caso de que no tengamos parcela suficiente, tenga una orografía difícil, una topografía complicada, pues vamos a la solución de la derecha, solución con filtros biológicos, donde de igual manera disponemos de una obra de llegada con su pozo de gruesos, con una reja de desbaste manual, un pozo de bombeo, tamizado.
We have a pump, a well, a relief area, an in-hof tank, as you can see, similar to the previous option. Then biological treatment
Una arqueta de recirculación de agua para recircular fangos a los filtros, la decantación secundaria y ya repetimos el proceso anterior. Aquí podemos ver unas fotografías de los humedales artificiales. En este caso es un filtro hub donde las macrófitas van situadas sobre este lecho de grava que podemos ver. Este es en fase de ejecución, justo antes de la plantación de las macrófitas. De la obra. Y esta es el paso siguiente, la misma depuradora, ya con las macrófitas, las plantas crecidas. Es otra foto de la misma depuradora. Otra fotografía. Y en este caso, pues esto, otra tipología. Lo mismo, plantas crecidas. Esta es la segunda opción que os comentaba, filtros biológicos, donde tenemos el esquema similar. Tenemos la obra de entrada, tenemos el tamizado, tenemos el tanque INJO, número 6, tenemos el pozo de bombeo a los filtros, 7, bombeo a 8, y el número 10 tenemos el decantador secundario, ya con las aguas clarificadas y vertido al cauce receptor. Aquí podemos ver un tamiz, una planta ejecutada recientemente. Esto sería una fotografía de los filtros y el relleno interior que tienen a la derecha. Aquí podemos ver fotografías de la construcción. Tenemos a la izquierda el tanque INJO prefabricado, a la derecha los decantadores secundarios. Cuando pasamos de los 999 habitantes equivalentes, pasamos a otra tipología. En este caso, disponemos de un biodisco. Los elementos de entrada son similares a la línea de agua, similar a la tipología anterior. Disponemos de una obra de llegada, que es el número 1. Disponemos la reja de desbaste, pozo de bombeo de agua bruta, número 3. El tamizado del canal, alivio en exceso de caudales, tanque INJO en una sola línea, tratamiento biológico mediante discos CBR, o RBC en inglés, Esta es la diferencia respecto al tratamiento anterior. Disponemos de una decantación secundaria, en este caso con un puente giratorio y medida de caudal. Al igual que la tipología anterior, disponemos de una arqueta para la línea de fangos, de una arqueta de purga de fangos, la arqueta de bombeo y el digestor primario integrado en el decantador, en el propio decantador. Aquí tenemos el esquema y aquí tenemos alguna planta. Tenemos a la derecha, podemos ver en blanco los biodiscos, en el centro vemos el decantador secundario y al fondo el edificio de control. Tenemos aquí otra fotografía de la misma planta. La misma planta con el esquema general. En el caso de poblaciones de 1.500 a 2.000 habitantes equivalentes, el esquema es similar al anterior, con la única diferencia que en lugar de un único biodisco se colocan 2 líneas. Podemos ver alguna fotografía. El esquema es similar a la tipología de 1.000 a 1.500 habitantes equivalentes. Tenemos a la izquierda el pozo de entrada, a la derecha tenemos el desbaste. Del desbaste las aguas pasarían abajo, número 6, al tanque Inhofe. Del tanque Inhofe a los biodiscos, aquí podemos ver que hay 2 líneas. Del tanque de los biodiscos tendríamos la decantación secundaria, medida de caudales y vertido al río. Tenemos alguna foto, aquí a la izquierda podemos ver un pretratamiento con el tamizado. A la derecha podemos ver el tanque Inhofe con una cubierta en poliéster reforzado con fibra de vidrio. Esta tipología de tratamiento. A la derecha el contenedor para los sólidos. Dentro el pozo de bombeo y a la izquierda el tamizado. En esta fotografía podemos ver dos biodiscos, la línea doble de biodiscos, un decantador secundario antes de su llenado y el decantador secundario pues ya en funcionamiento. Vamos a ver, puedo comentar también las plantas. Les estamos dotando en la medida de lo posible, siempre que tenemos espacio en las parcelas, para reducir el consumo energético de paneles solares. Es lo que podemos ver en la parte superior de la imagen. Para producir un autoconsumo, de tal manera que reduzcamos la factura energética. Estas plantas pues están automatizadas, se pueden operar en remoto, siempre requieren la presencia periódica de operarios que limpien las entradas, hagan el mantenimiento preventivo, pero son operables remotamente. Y bueno, poco más comentar. La elección de estas 3 tipologías ha estado basada en criterios económicos, pues reducir explotación, reducir en lo posible periodos de limpieza, personal que esté pendiente. Son plantas que se integran bastante bien en el territorio, sobre todo las macrófitas, pues es vegetación, tienen poco impacto visual, no tienen edificios altos. Son plantas que pasan bastante desapercibidas. Y bueno, pues este sería el grueso de mi intervención. Un poco más que decir tengo sobre este plan.
Thank you very much for your presentation. It seems we need a lot of water
Gracias a vosotros.
Oh, sorry. We can use treatment plans that can be easily disguised and not interrupt the landscape and be efficient and fully automated as you described. Thank you very much again. We are moving on to the next practice, but due to an unexpected obligation, the representative of the Laboratory of Analytical Chemistry of Athens University cannot attend our panel, but the presentation has been made available, and I'll present it on their behalf as well as I can. I'll share my screen. Let's see, okay. Do you see the presentation?
Yes, perfect, perfect, it's okay.
Okay, okay, very nice. Now, the title of the research project elaborated by the University of Athens and funded by the region of Attica, the actual title, as you can see here, is Assessment of Pollution, Contamination and Quantitative Investigation of Contamination Levels and Possible Sources of Pollution. The aim of the program was to apply the first in-depth environmental monitoring study in Greece using state-of-the-art analytical instrumentation and advanced data treatment processing techniques in order to investigate the occurrence of toxicity of thousands of chemicals. Their spatial and temporal distribution was evaluated, and based on their detection trend, the effect of agricultural and industrial activities close to the river, as long as climatic conditions that were also assessed. Asopos River Basin was selected since it is located northern of Athens and passes an area where 20% of the total Greek industrial production takes place. High metal concentrations and especially hexavalent chromium with the potential carcinogenic effects to human health have been reported in the literature in river and groundwater samples, and were mainly attributed to the discharges of industrial waste directly into the river without any prior treatment. Therefore, this environmental problem raised the consciousness of the citizens and attracted the interest of the competent authorities. Although there were many studies focusing on the analysis of heavy metals, until recently there was no data available for the presence and potential toxicity of priority pollutants and emerging contaminants. For those who are not familiar with the term of emerging contaminants, or better chemicals of emerging concern, we are talking about organic compounds that are not included in current legislations, but they have been recently detected in environmental samples. Therefore, the regulators seek for monitoring data and toxicity assessment results in order to evaluate and decide whether mitigation measures are required and if these compounds should be included in regular monitoring studies and future legislation. In January 2020, before COVID outbreak, during the meeting in Athens, we had the opportunity to meet each other in person and visit Asopos River Basin. Here are some snaps of our visit taken by the wonderful videos that are available in Big Data for Rivers YouTube channel. Moreover, detection of, yes, that's the sampling. The sampling strategy was meticulously planned by selecting a representative sampling points for its environmental matrix, river water, groundwater, drinking water, and sediments from the area, adding up to 148 samples in total. The seasonal trend of the detected chemicals was also assessed within 1 year period. For the physicochemical parameters, and the regulated conventional and priority pollutants, the environmental quality standards set in the respective directives were used for evaluating the results, whereas in-house toxicity prediction model was used to assess the toxicological behavior of the detected emerging pollutants. During the winter, daily samples were collected for 1 month period. In order to have representative daily samples and to be able to detect any contaminants released into the river anytime during the day and night, a composite 24 volume proportional sample was collected. Therefore, setting up autosamples able to operate non-stop for 1 month without any operational issues was needed. Batteries of high capacity and a solar panel to recharge them were used. We are in Greece after all, and we took full advantage of the sun even during the winter. Moreover, the position selected to set up the autosamples was crucial, since it was needed to consider that we should have easy everyday access to collect the samples, to protect them from any water floods due to extensive rain, especially during the winter. Specific measures like a steel cage with a lock were taken to prevent any vandalism or theft, considering their high cost. For the determination of emerging contaminants, generic validated protocols were applied to capture the molecular fingerprint of the environmental samples by extracting both polar, semipolar, and non-polar contaminants. High resolution
polares como no polares, utilizando una instrumentación espectrométrica tanto de líquido y gas mediante cromatografía de líquido y de gas para el análisis.
Sorry. Whereas for the data treatment, the samples were screened for the presence of more than 2,300 emerging contaminants through target analysis based on the database developed at University of Athens, and a wide scope regulatory data set of over 6,800 of chemicals that were used for suspect screening purposes available through Norman Network. The acquired analysis data include the molecular fingerprint of every analyzed sample. Therefore, the chromatograms were uploaded to the online digital sample freezing platform, which enables the suspect screening of more than 68,000 of chemicals from a regulatory database. And additionally, the samples are available for retrospective screening, meaning that new compounds can be screened in the samples without the need of any additional analysis. An in-house prioritization tool for non-target analysis named TreadProbe, based on deep learning artificial neural network, was developed at University of Athens for the automatic detection and classification of trends for the river water samples. The outcome of trend analysis and factor analysis is presented on the slide. The trend analysis graph with the red border on the left shows the detection trend during the winter. the winter sampling of the industrial chemical trimethyloctylammonium, which is used in the manufacture of plastic products. The red line presents the sampling point close to industrial activities, while the blue one is close to the river estuaries. What we notice is that there seems to be a maximum in the middle of each peak, which may be related to periodic industrial discharges into the river, so trend analysis was useful for the detection of spills. The first scientific article out of the project has been published in the prestigious Environmental Journal of Hazardous Material. Moving on to the results, 209 compounds were detected in river water samples. The contaminants were mainly industrial chemicals, pharmaceuticals, plant protection products, and their metabolites, transformation products. And based on the results, significantly higher concentrations were measured for selected compounds in the sampling point close to the industry and agricultural activities versus to estuary of the river. Moreover, detection of peaks for selected pesticides were related to the rainfall. For example, terbutaline was detected in a maximum of the sampling point close to agricultural activities 1 day after the rain due to the runoffs of the fields, and then 1 day after, due to rainflow, a maximum was detected in estuaries. Another observation was the detection of temporal trends. For instance, the herbicide metolachlor was detected at 30-fold higher concentration levels in spring compared to winter. Moreover, its metabolite, metolachlor ESA, was detected only in spring. Sorry. Here we see the results in groundwater samples where overall 93 contaminants were detected. Although there were samples withdrawn from close location, there seems to be a significant variation in their chemical profile. Plant protection products was the most frequently detected class of contaminants. Overall, 219 compounds were detected in all environmental matrices of analysis. The highlights of the results indicate traces of domestic and industrial wastes, the effect of rainfall and weekend in the detected loads. Based on the results and the evaluation of the toxicity of the detected contaminants, we added up to a list of 52 contaminants that could be included in a supposed river basin, specific pollutants, in order to be regularly monitored in the future. Compounds of the Water Frame Directive and the European watch lists were listed in this catalog, as long as emerging contaminants with high frequency of appearance or compounds exceeding their predicted non-affected concentrations values. The main challenges faced during the implementation of the project were to ensure continuous good operation of the auto samples and to protect them from vandalism or theft. The good cooperation with the local people was vital for the sampling and to collect information that could be linked to the research findings. This good practice could be replicated in other regions if state-of-the-art analytical equipment and highly expertise researchers in analytical chemistry are available. Professor Thomaidis and his team members are willing to collaborate, train, or provide consultants on such advanced environmental monitoring studies. Thank you for your attention. This is where I'll stop sharing. Okay. And give the floor to Mrs. Teresa Newpath, Interdisciplinary Center of Marine Environmental Research, and Mrs. Anna Gomes, Faculty of Engineering of the University of Porto. The floor is yours. You need to switch on your microphone.
Of course.
Okay.
Okay. It's are
Anna,
you listening?
Sorry, Anna, you also have to switch off the audio.
Sorry?
No, Teresa, you are okay. But now both. Okay, perfect.
Okay. Everyone are listening to me? Yeah?
Yes, okay.
So
yes.
I will show my presentation. Okay, so I'm Teresa Newpath from CIMAR, and now I will present briefly the NordWater project. The NordWater Consortium is composed by entities from the north of Portugal and from Galicia. The Portuguese institutions are CIMAR, that is the coordinator of the project, the engineering faculty of the Porto University, the Portuguese Environmental Agency, the Viana do Castelo City Hall, and the Aqua Museum of Cerveira. The institutions from Galicia are the University of Santiago Compostela, the CETMAR, the INTECMAR, and the ANABAM. This project is composed by 6 activities that I'll briefly describe in the next slides. Also, we can count with an advisory board composed by Águas da Galícia, Águas do Norte, a Confederação Hidrográfica del Minho-Sil, Junta da Galícia, and FASEC. This project was financed by Interreg Spain-Portugal, and the main aims are identify the main emergent pollutants and their transformation products in the watersheds of northern Portugal and Galicia, develop and implement new analytical methods and ecotoxicological tools for emergent pollutants with high risk, develop tools to increase the removal efficiency of emergent pollutants from wastewater treatment plants, transfer the obtained results to entities involving in the management of water bodies, and also perform education activities to promote literacy in the area. This project is formed for 6 activities, and I will describe those briefly. So the first activity, the main aim was the definition of the study areas for the emergent pollutants. In this activity, we developed analytical tools to study the emergent pollutants and their transformation products. Also, we prioritized the emergent pollutants that will be studied in the next activities. As you can see in this figure, we selected 24 points in surface water and 5 wastewater treatment plants in the north of Portugal and Galicia. We performed 2 sample campaigns to see which pollutants were in these selected sites. As you can see here, the number of emerging pollutants that we screened in this first activity. Also in this first activity, we detected all of these emergent pollutants that were detected in more than 50% of the sites. With all of this information, we prioritize the emergent pollutants that will be studied in the next activities. In the activity 2, we studied, or we are studying the transformation of these prioritized emergent pollutants, and also the concentrations of these pollutants in the surface waters and wastewater treatment plants that we select in the activity 1. In this activity, we perform 3 more campaigns, sampling campaigns, to determine the concentrations of the selected emergent pollutants. You can see in this table the main emergent pollutants that were selected, and also the maximum and minimum concentration that were obtained in the selected sites. Here you can see the contamination of all samples that we had, and obviously the samples from the wastewater treatment plants were more contaminated than the surface waters. But also, as you can see here by the red arrow, the samples for the Ave River is much more contaminated than all the other surface waters. In the activity 3, the aim was the development of nanotechnologies for the removal of emergent pollutants in the wastewater treatments. This activity, all these nanotechnologies will be explained in detail in the next talk by my colleague Ana Gomes from the Engineering University. In this activity, I just want to say that we also perform a toxicity screening with zebrafish to evaluate the efficiency of the developed nanotechnologies. And we observed that the toxicity was significantly decreased after the nanotechnology treatments that were developed by us. In the activity 4, the main aim was the development of ecotoxicological tools to assess the environmental risk of emergent pollutants. And for that, we performed several toxicity tests with zebrafish embryos with an adapted protocol from the OECD. Also in this activity, we are studying the mode of action of several priority emergent pollutants using next generation sequencing. In the last activity, the main aim was the transfer of knowledge and technology. We created and we are implementing a public-private partnership structure on the subject of the emergent pollutants. And also we are organizing several education activities to promote the literacy in this area of the emergent pollutants. In this slide, I just want to leave the link for our webpage, and where you can see in detail all the objectives, the activities, the results that are being produced in the scope of the NORWater. I don't have time to talk much more about the project. It's just one small presentation, because now my colleague Anna will present the activity 3 with the development of the nanotechnologies. So thank you very much for your attention.
Well, thank you, Teresa. Are you listening to me okay? Yeah?
Yes, yes.
Perfect.
Please go on.
Okay. I'm going to share. Okay, I think. Are you seeing? Yeah? Okay, so first of all, good afternoon. I would like just to appreciate the invitation and the opportunity to make this small presentation and presenting you a very small part, not all, of the work that is being developed by our research team under the NORWater project at the Faculty of Engineering of the University of Porto, FEUP, and the presence of all the people in the audience. So I'm Ana Isabel Gomes, and I'm a postdoc at FEUP, and I'm going to talk about our research under Activity 3 that is being developed in close collaboration with the University of Santiago de Compostela, that is responsible by the analytical determinations of the compounds that we are using the treatment tests, and CIMAR, that is responsible by the ecotoxicological assessments of our treatments. Here is our FEUP work team that is led by Dr. Vitor Vilar. I'm also part of this team. We have 3 PhD students and 1 master student that are developing their works in this project. So in the NORWater project, together with our partners, we have selected 19 compounds of emerging concern that are here in this table from different contamination groups. And we're using demineralized water first to optimize the processes, but then later we are also making tests with real urban wastewater collected after secondary treatment, and that we are spiking with these 19 contaminants at an initial concentration for each of 10 micrograms per liter. We are working with 3 different photoreactors, where 2 of them are membrane photoreactors. But for this presentation, I don't have the time to speak in detail of all of them. So I'm going to focus on the tube-in-tube membrane photoreactor and just have a very quick peek over the other 2 systems, the photocatalytic membrane reactor and the Fluelic. So looking to this first, this innovative tube-in-tube membrane photoreactor, we can see that it is composed by a membrane that is located inside a quartz tube, a tubular quartz, and with 4 lamps around it. Well, in this reactor, the membrane, it's not used to treat the water by filtration, as normally happens when we are talking about membrane technology and water treatment. But instead, this membrane acts simultaneously as a support for the catalyst and also a smart dosing system for a solution. We are using oxidants in the permeation, and polluted water is continuously fed into the annular space between the quartz wall and the membrane shell side, and the oxidant is rapidly driven to the water through virtually unlimited number of addition points along the membrane length. This allows a uniform distribution of the oxidant along the entire tubular reactor. In this system, our inlet and outlet are located tangentially to the inner wall of the quartz tube, and this creates an helical motion or movement of the water around the membrane. So dragging the solution that is being permeated from inside out the membrane to the bulk, resulting in a radial mixing homogeneity within the annular reaction zone where the contaminants degradation is occurring. So in this innovative reactor, we have multiple mechanisms that are synergetically contributing to produce the reactive species that will oxidize our contaminants in a single treatment unit, namely through photolysis of the oxidant in the presence of UVC radiation, photooxidation or photoreduction mechanisms by the holes in the electrons that are generated in the conduction, in the valence or conduction band of the photocatalyst, and even possible interactions between the catalyst and oxidants in the absence of radiation.
Anna, please, if you can speed up, because we are taking off the other's time, if it's possible.
I will try. So we have two similar reactional systems in our lab, one that we are using for the permeation of liquids, such as hydrogen peroxide and persulfate that are oxidants, or iron that is a catalyst for Fenton reaction. And we have a second system that we are using for the permeation of gas, in this case for ozonation treatment. We're applying different membranes according to the permeation of liquid solutions or ozonation of the water. And they can be applied in their pristine conditions or coated with photocatalysts. Titanium dioxide is a very well-known photocatalyst, or with a novel catalyst that was recently developed, silver molybdate. So here are some few results that I'm not going to enter in detail. I'm sorry for that. But with the 19 contaminants in demineralized water, I want to call attention that this reactor is working in continuous mode with a hydraulic retention time of just 6.1 seconds and with a very low UV fluence, 45 millijoules per square centimeter, which is comparably low to the ones that are used in real wastewater treatment stations. So we've tested different conditions. I'm not going to analyze each one, but I can say that with a membrane coated with a silver molybdate and permeating persulfate, in 6.1 seconds of residence time inside our reactor, we were able to remove more than 80% for 11 of the 19 selected CECs. Unfortunately, some compounds were not oxidized. For the iron permeation, we also had extremely good results when we applied persulfate instead of hydrogen peroxide. And it was even better than the previous conditions, with more than 80% removal for 13 of the 19 CECs. And I call special attention for high removal of melamine and PFOA, which were not removed previously. Finally, ozonation, and this I need to call the attention for even the lower hydraulic residence time that we have, 3.4 seconds, and we can see excellent results with 12 and 18 milligrams of ozone, which are doses that are used in real conditions. And UVC light did not improve any efficiency of this treatment. Attention I can bring to the removal of saccharin, which was not removed in the previous experiments. For the real urban wastewater, we also then tested each of the best process under distilled water. We had to increase a little bit the amount of oxidant and hydraulic retention time, even though they are quite low. And we still attain very interesting removals, especially for ozone and for silver molybdate with persulfate under UVC radiations. For ozonation, we also have an effective disinfection of the urban wastewater treatment. To finish, I just want to make quick mention to some published works with the second membrane photoreactor. I'm not going to talk deeply about it. We have published that beyond the oxidation tests, we also have already some ecotoxicological results from our treatments, and also we present different characterization analysis of the nano-engineered membranes that we develop. The final slide to mention that some ongoing work, in this case for the Fluelic photoreactor, we are concluding the lab scale and the pilot scale tests and beginning the installation of a pre-industrial scale photoreactor in an urban wastewater treatment plant that is located in the north of Portugal, where 4 Fluelics coupled in series will be tested under realistic conditions. And if possible, ecotoxicological tests will be carried out in situ by
toxicológicas in situ por parte de nuestro
emerging pollutants and transformation products, toxicity, ecotoxicity, and all the technologies to see what's happening and what we can do are very, very interesting. We quickly move to Mrs. Rocio Rena Royce, Amen Technology Center for her presentation. The floor is yours.
Thank you. Muchas gracias por la invitación a este seminario, al proyecto Big Data for Rivers. Antes de nada, mi nombre es Rocío Penarrois, pertenezco al Centro Tecnológico AIMEN y vengo a presentar una experiencia que tenemos en una de las líneas de medio ambiente del centro relacionado con los humedales construidos para la depuración de aguas. Es el proyecto Wetwine. Comparto la presentación y empiezo a comentaros. Aquí está. Este proyecto es una experiencia que hemos tenido hace un par de años, que finalizamos hace un par de años, en el sector del vino. Las bodegas, igual que otros sectores, tienen implicaciones ambientales importantes. El principal es el consumo del agua y la posterior generación de aguas residuales. Sobre todo, teniendo en cuenta que es una industria alimentaria, en medianas y pequeñas bodegas son muy estacionales y la producción del agua residual varía tanto en cantidad como en composición a lo largo del año. Por este motivo, los tratamientos convencionales no son todos los efectivos que deberían ser y por lo que puede ser interesante, ha sido interesante probar este tipo de tecnologías. Entonces, lo que intentamos en el proyecto fue aplicar el concepto de economía circular al sector del vino para su tratamiento del agua. Entonces, el agua que se produce en las bodegas, que se consume en las bodegas y que tiene que ser tratada, pasa por la planta Wetwine y se obtiene un agua que puede ser utilizada por su calidad en el riego del viñedo y un biosólido que puede tener interés como abono. Entonces, en este marco, en este contexto, surgió este proyecto, el World Wine, en donde queríamos poner una experiencia piloto, desarrollar una experiencia piloto y hacer una transferencia de esta tecnología al sector. Hacerles saber, desarrollar unas herramientas que le permitiera conocer un poco más a los usuarios finales, a la gente de las bodegas, a los viticultores, meterse en un campo que es un poco alejado del suyo. Entonces, este proyecto se desarrolló dentro de la convocatoria Interreg Sudoe, que es del sur de Francia, España y Portugal, y como comento, acabó en 2019. Hicimos un partenariado interdisciplinar con gente que venía del mundo del vino, gente que más veníamos de la tecnología y tratamiento de aguas como AIMEN y la UPC, y también contamos con la colaboración de bodegas que nos prestaron sus instalaciones. Entonces, un poco el esquema general de tratamiento que proponíamos era una primera digestión anaerobia, pero no para producir biogás, sino para solubilizar la fracción orgánica y además en ese mismo reactor hacer una separación física de la fracción sólida y de la líquida. La fracción líquida se trataría en humedales construidos y la fracción sólida, junto con otros residuos con un alto contenido en sólidos de la bodega, iría a los humedales de lodo. Entonces, un poco para poner en contexto qué tipo de tecnologías son estas, vamos a hacer una pequeña introducción. Los humedales construidos se conocen como tecnologías basadas en la naturaleza, aunque tienen otros nombres. Sobre todo es que intentan, por así decirlo, imitar a los efectos que aparecen en la naturaleza para la depuración de aguas. Entonces hacemos una simbiosis entre el suelo, la vegetación, los microorganismos que habitan en ellos para depurar las aguas. Y se ven un poco como alternativa a los tratamientos físico-químicos, mecánicos que se aplican habitualmente en grandes depuradoras. Aquí vemos en una foto un poco para explicarlo en qué consiste. Pues suele ser un lecho de grava y arena, en donde hay una vegetación y este marco entre las raíces de la vegetación junto a las arenas y las gravas permite un crecimiento de los microorganismos que son realmente los que juegan un papel muy importante en la depuración del agua. Por eso se ha visto que este tipo de tecnologías son capaces de eliminar sólidos, materia orgánica, nutrientes, pero también patógenos y contaminantes emergentes. Tiene bastantes ventajas, sobre todo por los costes de energía y de mantenimiento, porque es bastante sencillo, no necesita adicionar químicos, se integra muy bien en los paisajes, sobre todo en sectores importantes, en medios rurales. El principal desventaja es que requiere mucha superficie y entonces en plantas grandes, donde los caudales son grandes, pues puede ser limitante. Entonces, otro tipo de tecnología que ha surgido a partir de los humedales construidos es los humedales de sólidos. El funcionamiento, el mecanismo es parecido, solamente que el lodo que se quiere estabilizar se pone por la superficie de la grava y se producen procesos de deshidratación y de mineralización. En esta transparencia vemos mejor cómo funciona. Durante un periodo de 5 a 10 años se alimenta ese humedal hasta que se llena y se deja descansar durante unos meses para que acaben los procesos de mineralización, se retiran esos biosólidos y o se publican directamente en agricultura o pueden hacerse un compostaje. Pues ya metiéndonos directamente en la experiencia que hemos tenido en el proyecto, lo que intentamos era validar este tipo de tecnologías en un piloto. También ver que esos biosólidos pueden tener potencial como un abono y que su destino final no tendría que ser ni un vertedero ni otro tipo de otro tipo de destinos finales más costosos de manejar, sino simplemente depositarlos en el viñedo. También hicimos una serie de herramientas, la más interesante puede ser este software que aún está disponible en la página web y si queréis entrar en él y ver cómo funciona, permite un prediseño de una planta similar para una bodega. Está pensado sobre todo para bodegas pequeñas y medianas, que es un poco lo que vimos que este sistema puede ser interesante. Entonces, ¿por qué sobre todo nos parece interesante? Porque es donde realmente vemos en bodegas pequeñas y medianas la estacionalidad y las diferencias en la producción de calidad y cantidad de agua a lo largo del año. Entonces, esto suele ser un problema para los sistemas convencionales y que puede ser, en cambio, este tipo de sistemas basados en humedales construidos se pueden adaptar. Para ello, para validar su viabilidad, diseñamos una planta piloto con el esquema que comenté anteriormente y ya que nos permitiera tratar sobre un 10% de las aguas que produce una pequeña bodega. Entonces ya teníamos unos volúmenes de reactor de 1,5 metros cúbicos, con lo que ya era bastante grande, un humedal vertical de 30 metros cuadrados, un horizontal, otro también de otros 30 metros cuadrados, y el de lodos tenía una superficie total de 20 metros cuadrados. Esta planta piloto la instalamos en Galicia, muy cerca de la frontera con Portugal, en la bodega Santiago Ruiz. Aquí veis algunas fotos aéreas y aquí un poco las fotos de la construcción. Se intentó en la construcción, ya que el emplazamiento estaba en medio del viñedo, que fuera bastante integrado en el medio. Entonces se construyó mediante tableros una estructura que luego se cubrió. Fue importante para evitar escapes hacer una impermeabilización de las balsas. Aquí es donde se estaban rellenando los humedales con las arenas y las gravas durante la construcción. Esto es una fotografía una vez ya construida, empezando a poner en marcha, empezando a crecer la vegetación en los humedales. Como veis, se integra bastante bien en el medio, con el paisaje que se tiene detrás, de un bosque y de viñedos. Aquí tenemos otra imagen ya con la vegetación más crecida. Y un poco lo que hicimos durante todos los 3 años del proyecto fue comprobar, por un lado, que el biosólido que obteníamos, ese lodo estabilizado, se podía usar un fertilizante, a lo que hicimos ensayos agronómicos, y luego operar la planta en diferentes condiciones para ver que el agua que salía ya tratada cumplía calidad como para que se usara para riego también en el viñedo. Esto primero, vimos que aquí tenemos una tabla con una media del agua tratada. No voy a meterme mucho, tenemos publicaciones hechas y muchas más presentaciones mucho más profundas con todos los resultados, pero me parece que no nos darían para mucho más que 15 minutos.
So if you're interested, you can go and read them. But just to be brief, let me show you and tell you that the average
de materia orgánica, como fósforo, como amonio, estábamos siempre por debajo de los límites de descarga de vertido. Y lo mismo para las recomendaciones de riego, también estábamos por debajo de los valores recomendados que podemos tener. En cuanto a los ensayos agronómicos, se hicieron en las diferentes regiones y lo que intentamos fue comparar el biosólido que se producía en la planta wet wine con otro biosólido por otra planta de tratamiento de una bodega, un fertilizante orgánico comercial y un control. Y el resultado que se obtuvo fue que, sobre todo, que lo más interesante es que ese biosólido es seguro y que se puede incorporar en el viñedo, porque es fácil, económico y ecológico, para la forma más sencilla de hacer su gestión. Hay que recordar que, bueno, hay que decir que este biosólido se produce de forma puntual cada 5 o 10 años en una cantidad pequeña, por lo que no tiene un interés su uso como abono, simplemente es una forma de gestión lo más sencilla y que puede ser beneficioso para el viñedo, pero que lógicamente ni siquiera se produce en cantidades suficientes como para abonar un viñedo, sino es no es significativo esa producción. Entonces, pues, pero que no es necesario ni llevarlo a un vertedero ni llevarlo a ningún lado, se deja junto al viñedo más próximo, es lo que vimos en el proyecto. Y esto viene entroncado con otra parte de que hicimos del estudio que hicimos en el proyecto, que fue analizar el impacto ambiental de los sistemas de tratamiento de agua que hay en las bodegas. Cogimos 16 bodegas de España, Francia y Portugal, vimos sus sistemas de tratamiento y lo comparamos con el wet wine. Vimos que había aún bastantes bodegas, sobre todo en aquellas muy pequeñas, que su gestión consiste en llevar las aguas residuales, se las recogen y se las trata un tercero, con todo el impacto ambiental que tiene ese transporte. O tiene un sistema de lodos activados, que es el más común que tienen en el sector. Entonces, si comparamos con estos dos sistemas, vemos que el sistema wood wine que proponemos tiene un impacto de 2 a 14 veces menor que estos otros sistemas que son los más habituales. Entonces, un poco lo que vimos es que es un sistema que tiene mucho potencial, pero también tiene una serie de problemas porque es una nueva tecnología, necesita espacio, pero sí que tiene sobre todo muchos puntos fuertes, como pueden ser la operación sencilla y su mantenimiento fácil, y que tiene poco consumo energético, y la posibilidad de usar los fertilizantes y el agua recuperada, el abono y el agua recuperada en el viñedo. Entonces, un poco como conclusiones que vimos después de esos 3 años de operación, es que la planta wet wine, la planta piloto, tenía una operación muy robusta. Además, que se adaptaba a los cambios estacionales en el agua de entrada. Siempre se obtuvo una eficiencia de la eliminación, tanto en sólidos como en materia orgánica, muy buena, e incluso durante la vendimia, que era donde teníamos los picos de concentraciones, y que nos pareció que este sistema era muy interesante para aplicarlo no solamente en el sector, y con mucho potencial en general en el sector de alimentación. Entonces, también vimos que tuvo mucho éxito dentro del sector del vino esta pequeña aplicación, que por visual y porque además daba unos datos. No, es un prediseño, son unos primeros números, pero se podía hacer, puede evaluar el potencial tecnológico que podía tener una depuradora así. Entonces, pues eso daba unos valores de tamaño, pues cuántos metros cuadrados haría falta, de costes, por dónde andaría, sobre todo los costes de inversión, pero sobre todo, y mucho más importante, cómo se reducirían los costes de mantenimiento. También incluso daba unos datos sobre impacto ambiental, pues huella de carbono, del tratamiento y unas recomendaciones de legislación que revisar, ya que es una de las limitaciones que vimos durante el proyecto. La legislación en cuanto a aprovechamiento de agua tratada y lodo estabilizado, biosólidos como queramos llamarlo, pues es bastante farragosa y que no le permitía fácilmente a una bodega pequeña aplicarlo. Sí.
Si puedes ir terminando para dejar tiempo a los
Sí,
demás.
sí.
Vale, gracias.
Nada, ya estoy terminando. Simplemente comentar que, bueno, que este proyecto, tenemos más proyectos en este tipo de tecnologías, que también nos animó a, por ejemplo, a presentar el proyecto Varal en el sector lácteo, y hemos continuado con proyectos de humedales construidos en urbano. Por ejemplo, en Castilla-La Mancha tenemos el Intex, estamos participando en el proyecto Intex. También tenemos proyectos ahora en nuevos sectores, como puede ser el tratamiento de residuos urbanos con el Romeo o el Life Green Adapt, aplicando humedales construidos, no solamente ciñéndonos a urbano, que es en pequeñas poblaciones, que es lo habitual. Y nada, por concluir, animaros a visitar la página web, porque realmente sí que hemos elaborado así materiales interesantes que podéis ser, como puede ser un manual con explicaciones muy sencillas. Intentamos llegar al usuario final, con lo que son bastante didácticos y visuales. Y nada, que nos sorprendió sobre todo la aceptación del proyecto por parte del sector vitivinícola. No digo que de repente la gente se ha puesto a construir este tipo de plantas, pero sé qué presupuestos han pedido y que es una tecnología que tienen en cuenta antes de cuando llega el momento de instalar o modificar una depuradora. Muchas gracias otra vez por invitarme, ha sido un placer participar.
Thank you. From Natural Based Solutions, we'll go to IT. Mr. Stelian Brandt, Technical University, Cluj-Napoca. Please, the floor is yours.
Hello.
Hello. The floor is yours. You may start.
Can you see my presentation?
Yes.
Great. Wonderful. First of all, I was really delighted about the former presentations, which were quite very close to the ground of the challenges we are facing today in terms of the climate change and these tremendous efforts we have to do to improve the environment. So a lot of innovations I have seen in these presentations. Mine, even if it is about IT, I would say that is strong connected with what we have already seen, because in all these innovations, either it is about better water treatment or circular economy or reduction of the CO2 footprint, etc. We need a lot of data to optimize processes, to make things more effective as well as more efficient. Life cycle approach of all these innovations are necessary, and beyond of this, I would say that also the capacity to interconnect different initiatives together and to have a kind of holistic understanding of what is happening is, from my perspective, very important. So from this perspective, I will say that, and I invite the other colleagues in this panel to pay attention to my presentation, which is about the use of Internet of Things to monitor and control from cloud. In this case, it's an example with wastewater treatment plants, but with a little bit of effort and imagination, you can consider that we can expand this type of architectures beyond this use case to any kind of operations where we need monitoring and control over the life cycle of different data. The event of today, I have seen that it's about big data, so we somehow fall into the subject of today's event. So what is important to understand, at least from the perspective of the use case I'm going to introduce of wastewater treatment plants, nowadays, just to increase the resilience of these processes, we move more and more towards what we call smart grids of mini plants to treat wastewater. This is in the case of large cities, but as well, we have to consider these smart grids of interconnected mini plants towards a chains of villages. And why it's so important to have such kind of architecture is because we can increase the resilience, which is an important concept. We have to consider more and more for the days we come. We can have better predictability, cost effectiveness, flexibility in terms of adopting different technologies, the placement of the mini plants in the most critical locations, the reduction of the environment impact of polluted water, and also something which is important in terms of financial aspects of investments, lower captivity in one single supplier and faster scalability if it is necessary. By now, these kind of activities have been controlled and monitored with traditional so-called SCADA systems. They are fine in terms of technology, but with some drawbacks because you are captive in some service providers for data transfer. It's huge cost for implementing such systems and several other things. Therefore, by using these new technologies, Internet of Things, and the possibility to collect all data in cloud, we have the capacity that from a single center to monitor and to control a grid, network of plants. And beyond this, we have the possibility to have remote interventions and to expand the value added by provision of data over the whole life cycle of such installations. This is important because we can increase traceability of what happened or what is happening, transparency, and when we talk about the relation with citizens, to inform them, and even something more important, the preventive maintenance. How such architecture looks like, in principle, the difference with respect to local or traditional systems is that we have some modules that are capable to take data from the local plants and transfer in a very flexible way remotely in a center where we monitor and control this data. Of course, I'm not going to enter into very many technical details, but in local areas, in plants, there are the so-called PLCs that collect data from different equipments like pumps, from sensors of temperature, pressure, etc. But with these technologies, we can, in a very flexible way, to take this information and distribute to any kind of stakeholder. For example, looking to this slide, we can see that we can easily collect data from different driving units, from different sensors, and then transfer either to the cloud, where later on, using different application program interfaces to extract only data we need and transfer for further activities, for example, for analysis remotely using these APIs, as well as to the people involved in operations, in interventions, to alert instantaneously about different kind of incidents on mobile. Sometimes if you like to display on some social networks some results, we can do also this in a very easy and flexible way. Or also if we like to expand the system by adding new sensors or driving units, this can be done in a very flexible and easy way. And with data, we can then play to do different kind of analysis. Of course, from a technical point of view, there are several advantages. Just a few of them I'm going to introduce. We have a significant cost reduction related with the local control. For example, we do not need a lot of work memory locally because we can transfer data remotely, where in the cloud we can do a lot of analysis. Also, the local technology should not be of high performance, so just minimum involvement, so cheap models for PLC, etc. Another advantage is that we can add or remove functionalities remotely from the cloud control logic, and this is a very easy and fast way. We do not need to go in the field to do this, so we can do this remotely. Another advantage is commissioning. Commissioning can be done remotely, so in the field we should not put or locate experienced personnel to do these kind of jobs. And the architecture is scalable and reliable in the same time. Very easy, we can expand and develop these distributed networks. Another advantage is that we do not need to pay any more for static IPs, which usually is delivered by some service providers. And because the logic runs in the cloud computing, edging, we can correlate a lot of services to better understand what is happening in different locations. And remotely we can activate, in case of a crisis, different situation. For example, we can correlate the weather by collecting the data from these weather services or forecasting weather services, with activating different kind of units in the plants, manually or automatically, depending. And of course, the know-how for controlling the technological process stay now in the property of the utility company. So data do not belong anymore to some integrators, which is another big advantage. From a technical point of view, of course, is not very simple, I would say, but it is possible to have both public access to data or some data which are very sensitive to be located in a private cloud with specific protocols to access. And besides this, we have the possibility to integrate our information, our data, with other auxiliary data that are provided by third parties. Such an architecture, if we make a zoom in the previous slide, looks like this. It is interesting because using Internet of Things and the cloud computing, we had more advantages than collecting data only from the installation. We have also the possibility to collect data from different mobile units that are operating with these plants. And this is also an advantage to have a kind of understanding the processes, the supporting processes which are happening. There is a flexibility both to have local computation, but also to transfer this data remotely, both in some public clouds or private clouds where we have different security protocols to access this information, as well as possibility to encrypt this data, especially those which are sensitive. Moreover, the other advantage is that we can do analytics by collecting massive big data. And we know nowadays with the advancement in machine learning and artificial intelligence, this is possible, and this can offer us hidden aspects about the operation of the processes, as well as to act in terms of making preventive actions. I'm not insisting on the, let's say, technical aspects, how the connectivity is done between different layers of this architecture. So I will pass a little bit faster to this, but I would like to stop a bit on the big data side because of the topic of today's event. With machine learning, we can do a preventive maintenance. There are different algorithms that can be reliable in both classifying and doing regressions about the evolutions of different phenomena in the plants. Either if we use traditional machine learning algorithms or deep learning based on neural networks. In this respect, just considering the water pumps in water treatment, wastewater treatment plants, statistical data show that in 2-3 years, we have about 7-8 times failures of these pumps. And of course, by introducing in the system different sensors to monitor the performance of these water pumps, we can apply artificial intelligence to forecast the situation or critical situations or situation where we need to make preventive interventions. There are cases where we use over 50 sensors to monitor the performance of these plants with over 250,000 rows of data we collect, and the machine learning algorithms usually shows that in more than or about 93% of the data that are collected indicate a normal status of these water pumps. Close to 7%, it's about functioning, but with the need of fast repair. And only in 0.003% we have situation with broken status. But with machine learning algorithms such as random forest, it is possible to achieve 100% accuracy in preventing. And this is very important because usually with the scheduled interventions, we have seen that already the failure started with some periods in advance, but using machine learning and artificial intelligence, we can operate in advance and increase the reliability of these installations. It is also possible to reduce the number of sensors by having smart understanding of the operation of the system. For example, we use just a simple neural network with a 2-layer perceptron and only 3 data collected from the pumps, such as volume, flow, pressure, and temperature, to anticipate the leakages of these pumps. And a challenge for this kind of monitoring and preventive action is how we can operate with each individual pump, not at, let's say, at a statistical level, because each pump is unique in a way. And in this respect, the challenge is how to transfer from big data, which is now the traditional approach of artificial intelligence, to small data. And in this respect, there are some strategies we have started to test. One of them is called transfer learning, where we train the system by using big data from a certain field, which is close to the one we are interested in. And then we transfer the knowledge for the specific domain where we only have small data, and try to transfer from a generalized model to something which is more personalized, more customized. With this approach, is also possible to operate in a safer way, because we can design for every individual unit a so-called autonomous economic agent, which can interact with the other agents in the cyberspace, but in the same time to be connected to blockchain environment where every information is encrypted and protected by the blockchain technology. And in this respect, we can expand also the connectivity between, let's say, different plants, and in the same time to expand the connectivity at a larger scale, even regional, national scale, and to secure data, but for those that are responsible for monitoring and control, to collect relevant information for improving the future operation of such installations. Of course, there are different strategies to do this. Some of them are under the research of development today, but I would say that we are on the right track, because things prove to work also with this kind of more distributed strategies and architectures, where we can monitor only limited number of parameters, but using different stratagems, different tactics to make a correlations of those parameters with a large amount of parameters in the system, and then to create a novel artificial intelligence model, such as to analyze the performance of every unique unit. In this case, I'm talking about the water pumps. And of course, later on over the life cycle, to use the data collected from every unit to create a correlation model between the unique model of every pump and the generalized model. Thank you very much for your presentation.
All right, thank you for your presentation. We are running a bit late, but that doesn't mean we want to have an incomplete image of what you are offering. The information is overwhelming. Last but not least, Mr. Fernando Magdaleno Mas, Ministry of Ecological Transition and the Demographic Challenge of Spain. Thank you. Okay, we see your presentation.
Fernando, tienes que conectar tu audio.
Yes, thank you. Sorry I could not do it because of the type of screen, so it's now solved. Thank you so much for inviting us here today. We want to show one short and very brief presentation about one Interreg project we are currently developing between Spain and Portugal, and which has to see with the shared cooperation for the best management of the transboundary basins between both countries. I'm just switching on the presentation. Hope you can see it right well now. Is it okay?
Yes.
Okay, fine.
Yes, yes.
So, I was saying this project is...
Tal como iba diciendo, este es un proyecto Interreg y ha recibido el nombre de Albufeira y es el resultado de la convención Albufeira en la que han participado los dos países y entre las autoridades de gestión de ambas cuencas hidrográficas que tiene como objetivo
water bodies, including rivers, reservoirs, and transitional waters. This project has a number of partners. I will now explain with some detail particular goals, which I think are interesting for many of us here, and a bunch of activities which are designed to optimize the combined cooperation between both countries in this material, in this topic. The main purpose, as I was saying before, is to promote and protect the good status, the good conditions of those waters which are shared by both countries in the 4 districts which are boundary districts, like the Minho-Sil Basin, Duero, Tajo or Tagus, or Tejo in Portuguese, and Guadiana. And those 4 basin districts are big catchments, so they have a number of physical, environmental, and social complexities which require further attention from both governments and both countries. And we try to improve our knowledge, cooperation, and management about those shared water bodies. Finally, by those 2 aspects which are displayed on the slide, by harmonizing the methodologies for the evaluation of the status or the potential of the water bodies, and on the basis of a better diagnosis of the water bodies to better define the measures which may mitigate or restore the conditions of those sites. And secondly, to improve, or by improving the management of water-dependent protected areas and the more sensitive species and habitats which are sustained by those water bodies by generating methodologies that integrate the requirements of the water and biodiversity directives, which are of obliged commitment for both member states. So we want to increase knowledge and to increase cooperation on the basis of that knowledge, both from the water perspective and also from the perspective of habitats and biodiversity. You can see in that image in the lower section of the slide that there is a wide number of Natura 2000 sites of protected areas in Spain and also in the border area, in the cross-border area with Portugal, which require further attention to better improve how we are dealing with the management of the water bodies and of the species and habitats which are sustained by those water bodies. So it's a long range of sites. Most of them sustain important, endangered, or vulnerable species or habitats, and water management must be very well matched, very well coupled with water planning and management to optimize both aspects of land management. The main goals, I already highlighted them, are to increase knowledge about the status of the shared water bodies, fixing common criteria for a better evaluation of the condition in the past, in the present, and the future, and different scenarios of land use, of climate change, and other questions, to better coordinate how both countries are dealing with their management and with the planning, and improving the tools for the shared management of those resources. And also, which I would say it's also a crucial part of an increased management of waters, is to raise awareness of people, of society, about the kind of functions, about the kind of services which those places can provide to people and to nature, and also
sobre los servicios que la naturaleza,
the shared participation and also management of those places, because they are not ruled by administrations. They are part of the lives of the people who are living nearby, so they have to believe they are main actors of their future condition and of the way they can be giving back services to all those people. The project is based, as I was saying, in the 4 basin districts, which are shared by both countries. And this includes almost 70, particularly 68 water bodies, which include all kinds of rivers, of reservoirs, and also a small bunch of transitional waters in the upper and lower areas of the range, and also includes a high number of protected hectares or areas under the Natura 2000 network of the European Commission. So it's a number of almost 60,000 hectares for basin districts and those almost 70 water bodies. It's a high number of them, but that proves the relevance and the significance of the project and its results from both member states. The project, as an Interreg initiative, is co-financed by the European Regional Development Fund through one Interreg 5 Spain-Portugal program, and it's co-partnered by those 5 different entities, 2 big administrations in Spain, the ministry in which I work for the ecological transition and demographic challenge in Spain. Under this, the Water Directorate, where I work, which is dealing with the management of water in the whole country. A kind of twinned administration in Portugal, which is the APA, the Portuguese Agency for the Environment, which also has many of the competencies in water management and planning in our neighboring country. And also some research centers and some universities, like those other 3, which are shown in the slide. CEDEX, which is the Spanish Studies and Experimentation Center on Public Works, which is a very technical and specialized center for the research on, among other things, about water and ecosystems. And also for Portugal, the Institute Superior of Agronomy in Lisbon, and also the Institute Polytechnic in Leiria, which are also giving high valuable support in scientific and technical terms for the development of this project. The Albufeira project is part of those ACEs and objectives which are shown, which are, for any of you who are familiar with them, are mostly involved in land, water, and environmental aspects of these calls. So they are quite well located among the cooperation in Europe regarding such topics. And finally, I would like to highlight the 6 different activities which are part of the project, which I will just briefly review to let you see in a schematic way which are the main contents of each of them. First of those 6 is the harmonization of methodologies for monitoring the status or the potential condition of water bodies. Because as all member states in Europe, we have to be continuously evaluating or assessing which is the changes in the ecological status or the health of the river systems or the dam system or any kind of water bodies. But we're facing one difficulty, and this is that each country had been using in the past different tools, different methods to assess common aspects of those water bodies. So we needed urgently to better understand which was using each neighbor to assess the same thing in the boundary places. So this activity is oriented to intercomparing the results of the different campaigns which have been done in the past and presently in each country, and to try to translate in a feasible way which are the results, and then how we can understand is the real condition of our water bodies, and how each government can understand the results extracted from such campaigns. So this is the main goal of activity, and is being conducted by specialized people in both sides of the border, and we are getting interesting results, which we will in the near future to better align our common interest in the definition and in the protection of such places. The second one involves a quite connected action, which has to see with validating the methodology for the assessment and to create protocols based on activity one for an improved assessment of the ecological status or potential of water bodies for a future joint assessment of all those places. So this will include taking into account a wide number of samples and data, defining different protocols, and to be continuously comparing the results, and to be like crossing the utilization of such protocols in both countries to better understand which are the real results of each, and then to better compare and to create methodologies in future which will harmonize and better cross compare our results. The third, which I already commented on, is about integrating the requirements of the water and biodiversity directives, which has different perspectives in the region and have sometimes different goals, but they should be like the same thing, because the European Commission require all of us to understand the legal context in Europe, not as isolated pieces, but like a combined number of legislations which tries to improve the management and planning of land and water areas in the whole continent. So this activity is trying to understand which are the main habitats sustained by the water bodies in the boundary areas and transboundary areas, to extract from those places which are the most critical and sensitive species and habitats which are sustained by those waters, and then to understand which are the requirements of each species or habitat, with the final goal of designing measures which could combinedly improve the condition of the water body and improve the conservation status of those habitats and species. So this is currently being done by also a wide team of people who are analyzing with much detail which are those requirements, and trying to also increase the future actions which will be part of the basin plans in each basin. So this is also one major aspect of the project. And also it's, I was saying also before, that we have the social and more participative side of the project, which comprises different training actions, for instance, training technicians, managers, and show and capacitate all those people about which are the best potential tools to understand water condition and biodiversity condition, and to intermingle between each other for a combined future of management of such areas. And from the more social side or perspective of the project, there are also activities which are linked to water users at all scales, in small towns, in the border areas, people who are getting their livelihood from agriculture, from cattle, from any activity which is important in that area and which is partially or directly linked to water management. So we want them also to understand how waters are managed, how waters are assessed, to let them be a more active part of such management. And finally, there are also some activities for children in schools, and even some of these activities are in them are present schools from both countries, also with a goal of making them together like a team of small kids, understanding how their land is ruled, managed, and how they can be in future, as future important actors can be part of this initiative. The last activities are mostly devoted to the financial, legal, and administrative aspects of the project. And for this, we have one steering committee, which it is gathering every number of months, and which is trying to polish and to make all the cooperation for the project as good as possible. And finally, there is one communication and image plan with the webpage, which was published just a few days ago in Spanish, and also will be published in Portuguese and English next week, so just in a few days. And also we include a quite active presence in social networks, in all kind of the well-known social networks we all have today. And also we have presence by means of different leaflets, training materials, and other things. And all the partners of the project will have their own activities to disseminate and to make the results of the project more visible for anyone who is interested in water protection and conservation in our countries. The budget, just for any who wants to know, it's about 1.6 million euros. Of each, an important part, 1.2 million, are co-financed by the ERDF funding from Europe. And this is all. I leave here the website address of the project because there we will be placing all the results we get in the near future. So I think it will include very valuable information. It has already a number of materials, but we have more and more during this year. And I hope this can be of interest for anyone, both in Spain, in Portugal, or even outside the Iberian Peninsula, because it's an example of cooperation between countries in water management, and could be one demonstrative example of how neighbors can understand well and better each time about such a sensitive aspect of our combined management as is water and the ecosystem sustained by water. And this is all. Thank you so much again for inviting me here today, and I'll be happy in future to respond to any question anyone can have about this or any other water-related aspects in Spain. Thank you so much.
Thank you very much. You have very nicely connected the Water Frame Directive with the biodiversity directives, something we should not forget, because we tend to sort of isolate things, but they are all connected. We're running late, but still I risk around for a very short, let's say, opinion of you, from you about the transferability and replicability, cost, and people served by each one of the practices. I have in mind that we started with monitoring and detection of different technologies for pollutants and especially emerging pollutants. And then we went on to natural-based solutions such as artificial wetlands for the wastewater treatment recovery, Internet, the use of Internet of Things solutions related to wastewater treatment plants, and concluded with the last presentation where we saw the more spherical confrontation of the problems related to water bodies, biodiversity, activities of a public body. What do you think could be the main requirements for the transferability, replicability of your practice taking into consideration the cost and the population that will serve this practice. Who would like to start? No one?
If you want to start me with the constructed wetlands.
Yes, please.
Because I have the perspective of the project ended that, like with wine, let me continue in Spanish, please.
Okay.
Nuestro proyecto ya está terminado y nos ha permitido, es un proyecto donde tenía una parte muy importante de transferencia al sector, y era un sector del vino que no está familiarizado con el tratamiento de aguas. Entonces, ver unas nuevas tecnologías, creo que puede ser aplicado, esta opinión también la hemos visto en más sectores de la alimentación, más industrias de alimentación. Para ellos es más afín ver los humedales construidos, porque son tecnologías que se basan en la naturaleza. Para un agricultor o para alguien de la industria alimentaria, ver crecer cosas, ver las plantas, les parece muy sencillo ver cómo funciona, cómo es el mecanismo. El mantenimiento para ellos no les supone un esfuerzo, porque cualquiera de la gente que se dedica a cuidar los viñedos es muy sencillo hacer el mantenimiento de los humedales construidos. Ven que se integran muy bien con el entorno, que es una preocupación que tienen. La idea de que ese agua que sale ya depurada no se va a perder, sino que se puede utilizar para riego, lo mismo el abono, que también, como que lo ven un poco muy lógico todo, y que les parece muy interesante, sobre todo pensando en pequeños productores, como también pasa en mucho sector de alimentación, donde tenemos obradores artesanales, pequeñas industrias que necesitan depurar sus aguas, pero que a lo mejor no es que es una solución.
Industrial activities that maybe need to treat the waste.
Desarrollando AIME ya en el sector de las aguas urbanas, en pequeñas poblaciones. Es tecnología, no quieren una depuradora nunca a las afueras del pueblo. Para ellos es choca mucho visualmente, el tema de olores, siempre es una preocupación. Entonces, ver un sistema de este tipo donde se integra más en la naturaleza, favorece que la opinión pública y de los usuarios finales, y siempre ha sido muy positivo siempre que hemos trabajado en este tipo de tecnologías.
Right, thank you. Fernando, please.
Yes, thank you. Well, in our case, there are some results of the project which are most devoted to the particular conditions of the Spanish-Portuguese boundary water bodies, but there are other results of the project which are completely extrapolable to other areas, both in Spain or Portugal or abroad, because they have to see, as I was saying, and you were remarking also, about how to integrate the water and biodiversity policies, which is something which the Commission is demanding from all member states, because there are not clear tools nowadays put into action for such a combination. We normally come from different worlds, those who deal with water and those who deal with biodiversity. So these tools we are generating, I really believe they will be easily extrapolated to other places and could be one important milestone for other people throughout Europe for improving such integration. So that's why I'm trying to make visible such works, because I really think they are very well aligned with the Commission is asking all of us, and something which is also quite a big challenge for most member states, and is to understand how human pressures are creating responses in the water bodies. So how each water body, how each river is changing on the basis of the pressures and impacts which all activities are producing, and also how our restoration measures which come from the plants and other tools could be changing things in future under different scenarios of climate, of land use. So I think this is much in the center of something which is critical for policy in our continent. And I really think that the things we will show in the website will be of major interest for most people abroad. So I think it's quite a direct extrapolation, which is potentially possible here.
Thank you. Someone else?
Yes, I'm here, Stelian.
Yes, please.
Great, thank you very much. Actually, my topic, I would say that it's quite generous for any kind of area of applicability. We have to accept that we need data. We need data, and we need any kind of algorithms that automatically can interpret this data. Let's imagine that the architecture which I have introduced can be expanded to waste management, not just wastewater. We can monitor farms, plantations, vineyards, any kind of systems. And moreover, it is so important that even if small farmers or villages that have small installations, either for wastewater treatment or for waste management or for other purposes, can be easily integrated in a centralized unit where they can benefit afterwards of the interpretation of data, so they can benefit of the services in a shared way. And this is the huge advantage also for small investments, for small entrepreneurs. And of course, from this perspective, any of, let's say, the topics introduced in this presentation are reliable to adopt such technologies.
Thank you. Anna or Teresa? Would you like to comment? Oh, Teresa, yes, please.
Okay. So I think our project is also very important because we are detecting the concentrations of the main emission pollutants in several places in North Portugal and Galicia. So this information could be passed for the authorities, and it is a good advance in the quality, or trying to improve the quality of the water if the authorities know what kind of emission pollutants are in more concentration in the waters. Also, the nanotechnology that the engineering university are developing, that Hannah talked about. It's very important because, as I think you understand, that this new technology can reduce significantly many of emission pollutants. So if this kind of technology can be applied in a bigger, not only in laboratory, but in a bigger way, it will be very important to reduce the contamination in the waters. So I think these are the main important inputs or outputs that the NorWater can give to the society.
Thank you. Our representative for Public Infrastructure and Environment Society of Castilla y León, would you like to make a comment?
If I can just compliment, complete a little bit what Teresa said regarding the transfer or the implementation of the technology that we are developing at Faculty of Engineering regarding the treatment of wastewater, the tertiary treatment. In fact, only one of the configurations will be tested at a pre-industrial scale. We aim to do that also for the remainings, for the other two systems. I can say that at this time in the European Union, we don't have yet legislation regarding the removal of these contaminants in the discharge of the wastewater treatment plants. However, that will be in the future, I'm absolutely sure. You have already discharge removals that are mandatory in the wastewater treatment plants discharge regarding some contaminants in the Swiss legislation. And so I think that in a nearby future, we'll also have this kind of demandings from the European regulation. And when we will have them, the conventional wastewater treatment plants that are now at work will require to make an upgrade in the tertiary treatment. So I believe that the research that we are doing will give an answer to that challenge that we will have soon. Thank you.
Thank you. Mr. Xavier?
Javier creo que Javier no sé si habrá o no tendrá nada que aportar, dado que ellos solamente, solamente no, son los encargados de la construcción de las plantas depuradoras dependiendo de los rangos. Me imagino que pero bueno, yo creo que si alguien no tiene, o si alguien no hay ninguna pregunta más, Antigoni, con tu permiso, creo que podíamos dar las gracias a...
No, I have no... Yes, please.
Ok. Bueno, podíamos dar las gracias a todos los ponentes, a los coordinadores y al público que nos ha seguido en esta jornada, en esta intensa jornada interesante, la cual, bueno, pues como he comentado en los inicios, tenemos que acogernos a estos formatos, pero bueno, sobre todo darle las gracias por el volumen tan importante de información, por las soluciones que se han puesto y se han mostrado, de las cuales todos podemos aprender, y sobre todo, bueno, pues por la calidad de los ponentes y de los proyectos, que muchas veces, si no estás en este tipo de proyectos, de seminarios, no te das cuenta de todo el conocimiento que hay para que recursos tan importantes como lo que es el agua, para que cuencas hidrográficas españolas, o sea, internacionales de ambos países, estén en un estado óptimo, y que después pues, pueda haber una actualización de toda esta información, y pueda haber un compartir que nos lleve también pues, a un desarrollo económico de todas estas áreas. Yo solamente me queda indicar que mañana tenemos a las 10 de la mañana empezamos las visitas de estudio, ¿de acuerdo? Hemos intentado, ya lo verán, pero bueno, hemos intentado hacer un formato, unos vídeos para que después lo que no han podido ver, como no como no podéis estar con nosotros físicamente, pues bueno, intentamos haceroslo llegar. Y bueno, pues mañana empezamos a las 10 y después pues también a las 12 tendremos pues la parte de los planes de acción y de los matching pair. Por mi parte, volver a dar las gracias a todo el mundo y mañana nos vemos, ¿de acuerdo? Gracias.
Thank you very much.
Thank you so much.
Goodbye.
Bye.
Thank you.
Thank you all.
Bye, thank you.
Bye.
Thank you.